All right, thank God it's Friday. Blessed, wonderful morning po everyone. Today is November 27, 2020, and we are back for the last session of One Stat at a Time, a webinar series on basic statistical tools and techniques in research. Magandang umaga po sa ating mga early birds sa ating FB Live. Medyo lumalamig na po ang panahon, no? Talagang papalapit na ang Christmas. Kina Celine, kila Carl, kila Mary Rose, kila Michelle, kila Rafi, kila Grace, good morning sa mga early birds natin dyan sa FB Live. Please let us know where you are watching our session today at taas po ang kamay ng mga present pa rin hanggang ngayon sa ating session 3. Sige nga po, let us know sino yung mga perfect attendance. Simula po session 1 on move on from your experiment, basic experimental designs. And then session 2 po is it's not complicated, analysis of data from a single, two, or more populations. Then ngayon po, session 3 na tayo. Wow, congratulations po sa mga ever-present. Talagang walang absent sa pagtutok sa ating webinar series. I hope ngayong umaga mas lalo pa pong madagdagan yung ating mga learnings tungkol sa statistics. Again, our session today is an extensive webinar. So this will be a 3-hour webinar or 3-hour long webinar. But in the middle of the session po, we will have a 15-minute break para ma-refresh lang po tayo ng kaunti yung ating mga brain cells. Then balik po ulit tayo sa balik tayo sa second part ng discussion. Alright? Ngayon po, kung wala pa po dito ang inyong mga kaklase, yung inyong mga kaibigan, bisingin na po natin sila, itag na po natin sila sa ating FB Live. Huwag din pong kalimutang i-share yung ating video para naman po sama-sama tayong matuto, malinawan at ma-appreciate ang statistics, lalong-lalo na po ang correlations. Sa kabuuan po, meron po tayong tumataginting na 6,070 registered participants. Grabe po, no? Again, thank you so much for taking interest in this webinar series. Together, let's move forward with our research, with our studies, one stat at a time. Okay, I hope on board na po tayong lahat. Time check, it's 9:03 in the morning. Welcome to One Stat at a Time, a webinar series on basic statistical tools and techniques and research. And we are on our third and last session entitled, Are We Correlated? Relationships Among Variables. Once again, I am Cheryl Hermosa Ebron, the University Extension Associate and Training Coordinator of UPLB Learning Resource Center, and I will be our session's moderator for this morning. Once again, just a few friendly reminders for today's webinar, guys. Always keep your comments respectful at all times to the speaker, moderator, and to your fellow participants. And if you have questions, feel free to comment them down below the comment section box. Our speaker will address them after the discussion. And most importantly, please ask questions relevant to the topic. Okay? And then lastly po, please, again, do not forget to answer the evaluation form after the webinar. Our team, hashtag Team LRC, will deeply appreciate for your comments and suggestions. Once again, the deadline of submission of responses will be only until 7 p.m. today. Make sure that you answer the evaluation forms to get your e-certificate of participation. Ayan, sa mga hindi po makakapanood ng live today, dahil meron po kayong sabay na klase or sabay na ganap sa umagang ito o kaya naman po hindi kaya ng data ninyo, huwag po kayo mag-alala. You are always in our mind po. We will upload all of our sessions sa aming YouTube channel. As of now po, meron na kaming 1,030 subscribers on YouTube and still counting. Salamat po. Kaya don't forget to like, share, and subscribe. And wag din pong kalimutang i-click yung notification bell para updated tayo palagi sa ating mga videos. Also, follow us on our Instagram and Twitter accounts. Pwede nyo rin pong mapanood yung replay ng ating session sa Facebook page po ng LRC. I-like nyo rin po yung page namin. As of today, we are now close to 42,000 strong followers sa ating social community. Maraming salamat po sa inyong suporta, and let's continue to achieve academic excellence. Kaya po yan, basta sama-sama. And once again, yung ating official hashtag po sa ating webinar series na One Stat at a Time, ayun na nga po yun, hashtag One Stat at a Time. Gamitin niyo po yan para madali po nating makita lahat ng resources regarding this webinar sessions using that hashtag. Okay, sa umagang ito, handa na ba ulit tayo? G pa rin ba kayo, guys? Well, kung G na G ka pa, G na G pa rin kami. Kaya tara na, let's do it one stat at a time. So to begin with, let's now have a short energizer. So sa palagay ko, mga expert na yung mga present simula session 1 sa ating menti.com. Alam na alam nyo na po ang gagawin. Go to www.menti.com and then use the code that you see on your screen. It's 2832505. You can also see the code on your screen. Ayan po, nakikita nyo po yan. Then there are 2 questions there. Let me just post po yung ating link para dun sa menti.com para naman po sa mga hindi pa po nakaka-try mag-menti.com, kayo po ay makasunod. Ano po? Okay, ayan. It's already posted there. Let me just pin it para po kita natin lahat. I hope you're seeing it. And then let me also share my screen so that we can all together see the live results of our menti.com. Hanggang ngayon po ako po ay na-amaze sa menti.com. Alright, ayan. Ang ating first question is, what household chores do you actually love to do? Ayan. Dahil tayo lahat ay nasa bahay na po, hindi tayo pumapasok, hindi tayo opisina or yung iba, combination ng work from home tsaka physical reporting. Ngayon, ano kaya yung pinaka gusto mong household chores? Meron tayong washing the dishes, doing the laundry, cleaning the house, cooking, ironing of clothes. Akin po lahat, wala po. So 7 choices yan. I'm now seeing on my screen 75 people answering our menti.com. So far, nakikita natin sa ating screen, leading ang cooking. Sumusunod po ang akin po lahat. O, di ba? May muscle dyan nakita. Parang akin lahat. Sumakay ka pa. Ayan. So, second po yan. Yung pangatlo ay yung cleaning the house. At meron pong wala po. Talaga, wala akong love na household chores. Ako po personally, ang pinakagusto ko pong household chore ay gawaing pangbahay ay washing the dishes. Paghugasin mo na ako ng pinggan kahit maghapon pa yan, okay lang sa akin. Kasi nag-enjoy po ako yung pag kini-clean mo yung plates, tapos tinuruan ka ng nanay mo na dapat hindi siya malangis. Kasi kundi reject yon. Okay? Ayan. Sige po, keep it coming. Yun pa rin, cooking pa rin talaga, no? Ano pala kayo, most of you guys, para mga chef pala kayo ngayong quarantine. Sa inyo ang cooking. You enjoy cooking. Okay, I guess that's it. We have 141 na nag-answer sa first question. Now, let's move on to the second question. Okay. Ito po, bigyan natin ng background ng ating resource speaker this morning. Kung naka-attend ba kayo nung webinar po ng LRC, which is on data visualization. It's actually part of the Making Sense of Data webinar series by Sir Enzo. That was last July 1 and 3, I guess. Yung data visualization is the second day. So, sino po sa inyo ang naka-attend ng webinar po on data visualization? Okay? Oh, okay. Meron tayong no. 50 yung, ayan, most of you hindi naka-attend, no? Pero merong 16 na naka-attend at nakita yung ating webinar on that. Actually, we have a recorded version or session of that on our Facebook page and also on our YouTube channel kung interesado po kayo na makita yung webinar series na Making Sense of Data. Okay? Sige, paabutin lang po natin siguro ng 150 kung kaya para malaman po natin kung madami po ba ang hindi naka-attend. So far, madami, no? Nasa 110. Only 27 yung nakakita nung ating webinar series. Okay, so most of you ay hindi nakita yon, no? Yung webinar series natin na yon. Okay, I guess that's it for our energizer. Thank you so much for answering our menti.com. At sana na-refresh tayo at na-energize pa tayo, no, para sa ating session this morning. So thank you so much for participating. Moving forward, let us now proceed to the main part of our session. Allow me to introduce to you our speaker for this morning. He is an assistant professor at the Institute of Statistics of the College of Arts and Sciences of UP Los Baños. He finished his Bachelor of Science degree in Statistics and Master of Science degree in Statistics with a cognate in Information Technology here also in UP Los Baños. As an instructor in statistics, our speaker is teaching several undergraduate courses in statistics ranging from statistical theory to statistical methods. In 2016, he was awarded as the 2016 UPLB Outstanding Teacher for the Physical Sciences Junior Faculty category. He was also given the 2019-2021 One UP Faculty Grant Award in Statistics for outstanding teaching and public service in UP Los Baños. Apart from teaching, our speaker served as a technical consultant for several institutions such as the Philippine Statistical Research and Training Institute, Manila International Airport Authority, Technical Education and Skills Development Authority or TESDA, Southeast Asian Regional Center for Graduate Study and Research in Agriculture or SIRCA, and Strategic Research and Development Center Incorporated, or known as Strand Asia. He has also delivered several training programs to various agencies on topics such as data visualization, infographic design, building computer assisted personal interview or CAPI systems using CS Pro, web page development, data management and analysis using MS Excel, gender statistics and analysis, and statistics and probability for senior high school teachers. Here to share with us relationship among variables, please welcome in the Zoom space, Professor John Lorenzo A.
Yan. Good morning po sa ating lahat. Isang maulan na umaga sa ating lahat. So sana po ay okay po kayo kung nasaan mang parte kayo ng Pilipinas or kung meron tayong mga bisita dito sa ibang parte ng mundo. Okay. So as Ma'am Cheryl have said a while ago, this is the last installment of the One Stat at a Time, a webinar series on basic statistical tools and techniques in research. So nakita ko po kanina sa comment section, madami nagsabi na andito pa din sila, third day na nila. So since nung first day po natin nung Monday, okay, nakasubscribe pa rin po sila dito sa ating webinar series. And for today's webinar, we will deal with the relationship among variables. So how do we analyze relationship among variables? So are we correlated? And before I start my discussion, I would like to first ask you this question. How was your sleep last night? Did you get enough sleep? Yan. Ako po dahil kailangan natin mag-rest para sa webinar na ito, ay ako po ay natulog for siguro around 7 hours. Okay? For 7 hours. Okay? Pero yung iba sa inyo, nakatulog po ba kayo? Gaano katagal yung tulog ninyo last night? Huwag kayong mag-alala, tatanungin ko yan sa inyo later. Okay? Pero for whatever reason that is, okay, baka yung iba sa inyo, sabi nga po ni Tutsi Guevara sa kanyang kantang Kaba, yan, di makatulog sa gabi sa kaiisip, yan, dahil nga ang tema ng ating webinar series ay tungkol sa pag-ibig. Okay? So baka may iba kayong iniisip, okay? Kaya hindi kayo nakatulog kagabi. But anyway, kidding aside, okay, I am asking this question because we are to explore the variables related to this study that I will be showing in the next video.
To a CBS 4 News.
Let's just check. All right.
To a CBS 4 News health alert. Let's be honest, most of us do not get enough quality sleep. Now, another study shows how that may affect your heart health in a negative way. As a nurse in a sleep clinic, Scott Moran knows how important a good night's rest is professionally and personally.
I was diagnosed about 15 years ago with sleep apnea. I finally had an answer to why I was so tired.
New research shows people who sleep less than 6 hours a night may be at increased risk for cardiovascular disease. The study in the Journal of the American College of Cardiology finds an association between poor sleep quality and having more plaque buildup in the arteries throughout the body. Dr. Deepak Bhatt is a cardiologist at Brigham and Women's Hospital.
Having plaque in the arteries, say to the heart, is what predisposes to heart attacks, and having plaque in the brain is what causes most forms of stroke.
Previous studies show lack of sleep can also increase other heart disease risk factors like blood pressure, inflammation, and obesity. But too much sleep could also be bad for the heart. The latest study suggests sleeping more than 8 hours a night may increase plaque in the arteries, especially for women.
Probably the sweet spot for sleep duration is around 7 to 8 hours. But I should say, though, that's 7 to 8 hours of really good sleep because, again, the quality of sleep matters. It's not just the quantity.
That's the amount of sleep Scott aims to get each night. He encourages anyone having trouble sleeping to see a sleep specialist.
Snoring, waking up more tired than when you went to bed. Any symptoms like that, your alertness doesn't seem, you're having memory loss issues, definitely get it checked.
With the help of a CPAP machine, he says he feels well rested every day. And the study also finds that people with short disrupted sleep are more likely to drink alcohol and caffeine.
It's a problem for so many people, huh?
And for nightsiders, we sleep too much.
You got to get your Z's.
All right. So for this activity, as a motivation to our discussion for today, let us explore the two variables mentioned in the video. So please go to bit.ly/are we correlated, and you will be asked two questions. Okay. So the first question is, how many hours of sleep did you have last night? And the second question is, what is your resting pulse rate? So if you are not familiar with how to measure your resting pulse rate, the link provided here in the slide, and it will be also provided on the comment box of our Facebook feed, okay, will tell you how to measure your resting pulse rate. So I will give you 5 minutes to perform this activity. And while we are populating the responses, you will see a real-time scatter plot on your screen. So once again, I will repeat the instructions. Please go to bit.ly/are we correlated and provide the answers to two questions. First question is, how many hours of sleep did you have last night? And the second question is, what is your resting pulse rate? So the instructions on how to measure your resting pulse rate is also provided in the online form. All right, so 5 minutes to perform this activity. And at the middle of the 5 minutes, we'll examine and explore the real-time scatter plot that I have prepared for you. All right, so let us now go to our time scatter plot. So for that's if you realized, that's why I asked Ma'am Cheryl to ask the participants for today if they attended the data visualization webinar, because I mentioned the scatter plot several times during our data visualization webinar series. So if you are not familiar with the scatter plot, don't worry, we'll also be discussing this later on. But just a very brief description, the scatter plot is a data visualization tool that we use to examine the relationship between two quantitative variables. So in our scatter plot, we are seeing two quantitative variables, the number of hours of sleep last night and the resting pulse rate. So through this scatter plot, let us form some notions about the relationship between these two variables. So kung napansin niyo po kanina doon sa ating video, ang sabi doon ay the lack of sleep or sleep deprivation affects your heart rate. And we will see, or we will check that conclusion or that statement through this scatter plot. All right. So let's just wait for the others to key in their responses. Ang saya naman po nung nandito. Yan, oh, haba ng tulog niya last night. Yan, more than 10 hours. Yan. Meron naman talagang very sleep deprived. Yan, so nakikita natin dito around sila yung mga slept for just 4 hours last night. So by visual inspection, kita natin na most of the participants slept for around 6 to 8 hours last night. In fact, yun naman po yung recommended, di ba po, for adults. Alright? So perhaps let's just wait for 2 more minutes. Okay. So are you enjoying yung real-time scatter plot natin? And so inisip ko pong maigi kung paano natin mapapakita to. Unfortunately, wala pa yung scatter plot sa menti.com. Yan. So kaya naisip ko na lang po na i-populate siya using Google Forms. Alright. Alright. So stop na po tayo. So we are, let's form this picture in our mind. Okay? Babalikan po natin ulit mamaya itong scatter plot na nakita natin in this activity. Alright, so going back to our discussion or to our lecture for this webinar for today, let us now proceed with the learning objectives of this webinar. So at the end of this webinar, you must be able to identify the most appropriate tool for analyzing the relationship among variables and interpret the results obtained from a statistical software. So yung objective natin for today is actually similar lang din po kung ano yung natutunan natin or kung ano yung objective na na-present from the webinars on last Monday and last Wednesday. Alright, so for our topics for today, first is we will deal with the measures of association. So under this topic, we'll talk about the Pearson's correlation, the Spearman's rank order correlation, chi-square-based measures of association, and some other measures of association based on the type of the variable that we are studying. And the second part of our webinar will deal with regression analysis, wherein our discussion will concentrate on the simple and multiple linear regression analysis, and I will provide an overview or a very brief introduction of the logistic regression analysis. All right, so let's start our discussion with the measures of association. And first, let's talk about for the variables in at least interval scale. Okay? Now, if you will recall, again, basic concepts in statistics, if we say that a variable is at least interval in scale, that means the variable is quantitative. Okay? So our first discussion will deal with variables that are quantitative. And as you have seen from our activity, the easiest way on how to display the relationship or examine the relationship between two quantitative variables is through a scatter plot. So the scatter plot is a data visualization tool that is used to determine if relationship exists, whether it is linear or nonlinear, between two quantitative variables. Of course, you can construct a 3D scatter plot, so that would now entail examining the relationship of more than two variables. Okay? Pero dun po muna tayo sa basic. Let's just consider two quantitative variables. And from this scatter plot, we can see if there is a linear or a nonlinear pattern in our data set. So since we are dealing with two variables, kasi baka marinig nyo po mamaya itong term na to sa akin, so in statistics, if we have a data set consisting of two variables, we call that as a bivariate data. So madali naman pong intindihin yon kasi as the name implies, bivariate. So bi, dalawa. So a data set with two variables, again, we refer to it as a bivariate data. So from our bivariate data, again, we can check if a linear or a nonlinear pattern exists. If a linear pattern exists, we can check if the two variables are positively associated or negatively associated. Or if there is a linear pattern, what other, or if there is other forms other than the linear pattern that is present What is it? Quadratic po ba ito or some other forms of linear relationship or nonlinear relationship present in our dataset? Now, quickly lang po, if we are to examine our scatter plot, take note that let's just switch to a pen. Take note that under this scatter plot, we see that there is a positive linear relationship. It seems that the two variables are positively linearly related. That is, as your variable x increases, your variable y also increases. On the scatter plot on this portion, it seems that the two variables have a negative linear relationship. And what does it mean? It simply means that if your x increases, your variable y tends to decrease. While the scatter plot on this portion shows that there is no association between the two variables. All right? So moving on, of course, the scatter plot is just a visual tool, right? So it is prone to your subjective judgments. But if we want to come up with an empirical measure of the relationship between the two variables, we'll use the idea of the scatter plot for a quantitative measure. And that is your Pearson's correlation coefficient. So the population Pearson's correlation coefficient is usually denoted by the Greek letter rho. So in some statistics textbooks or in most statistics textbooks, you would see that the Pearson's correlation coefficient is often denoted by rho. While if the correlation coefficient was based on a sample, you would see that it would be denoted by R. All right? Now, what is the Pearson's correlation coefficient? It is simply a measure of the strength of the linear relationship between two quantitative variables. So I'd like to emphasize this statement. The Pearson's correlation coefficient is only a measure of the strength of the linear relationship. All right? Now, some features of the Pearson's correlation coefficient. The first one is its range. The coefficient has possible values ranging only from -1 to +1. And as you can see from the possible values, the second feature is its sign. And the sign simply indicates the direction of the linear relationship. So based on these possible values, a coefficient value that is near +1 would indicate that there is a strong positive linear relationship, while a coefficient that is near -1 would indicate that there is a strong negative linear relationship. But later, we will come up with a more useful way of how to interpret the magnitude of these coefficients. All right, so for the third feature, the magnitude, and for the Pearson's correlation coefficient, a value of 1 indicates a perfect linear relationship, while a value of 0 means no linear relationship. So, katulad po ng sabi ko kanina, we will use the idea of the scatter plot for the Pearson's correlation coefficient. Paano po yon? Kanina, doon sa examples natin ng tatlong scatter plot, we are seeing in an imaginary straight line. Now, yung distance po ng bawat points doon sa straight line na yon, yun yung nagiging basis natin for the computation of your Pearson's correlation coefficient. So meaning, if your Pearson's correlation coefficient is exactly equal to 1, then all the points in your scatter plot would lie exactly on that straight line. All right? And again, I would like to emphasize that a value of 0 exclusively means that there is no linear relationship. Now, as I have mentioned a while ago, there are useful ways on how you can interpret the magnitude of your coefficient. So we usually use this rule of thumb to interpret the strength of the linear relationship between two quantitative variables. So if it's between 0 to 0.2, we say that there is a very weak linear relationship. If it's between 0.2 to 0.4, we have a weak linear relationship. If it's between 0.4 to 0.6, a moderate linear relationship. between 0.6 and zero point 0.8, that's a strong linear relationship. And zero point 0.8 to 1, that's a very strong linear relationship. Okay? But of course, just like in other statistics or other descriptive measures that we have, some of these statistics would be discipline specific. Now, what I'm trying to say is that a coefficient value equal to zero point 0.8 may be already a strong indication of linear relationship for those in the engineering. But for those in the medical or psychological researches, a strong linear relationship is somewhere on the zero point 0.6 interval. So again, these measures are discipline specific. Okay? But if you aren't able to find a rule of thumb that is exclusive for your discipline, you can use this as your guide for interpreting the magnitude of your correlation coefficient. The fourth feature is the strength. And take note that the Pearson's correlation coefficient only informs us the strength of the linear relationship between the two variables. It cannot inform us of other forms of linear relationship or other forms of nonlinear relationship. Okay? We cannot see that in a correlation coefficient. And aside from that, you have to remember that a correlation coefficient that is exactly equal to 0 does not necessarily mean that there is really no relationship between the two variables. Di ba po in-emphasize ko kanina, a value equal to 0 indicates lack of linear relationship. So if r is equal to 0, yes, there's no linear relationship, but there can be other forms of relationship that is present between the two variables. Alright, so I hope nakuha po natin yon. And the fifth feature is the correlation or the Pearson's correlation coefficient is unitless. That means the absolute value of the coefficient will not change if the units of measurements are changed. This only indicates that the Pearson's correlation coefficient measures the inherent relationship of the two quantitative variables. And lastly, the Pearson's correlation coefficient is symmetric. So the value of the correlation coefficient does not depend on which of the two variables will be assigned as x or y. So in other words, the correlation between x and y is just the same with the correlation between y and x. All right? So here are some reminders on the use of the scatter plot as well as the Pearson's correlation coefficient. First reminder, do not use the Pearson's correlation analysis if the relationship is explained better by a different curve or the pattern is not linear. So if you were here in our data visualization webinar series, I have shared this GIF or this picture to you before. So this shows 12 data sets, each having x and y variables, wherein the x and y means, the x and y standard deviations, and the correlation coefficients are all the same. Okay? But if you examine the scatter plot of these two variables, you would notice that there is a different data structure for each of these 12 data sets. And there is a danger if you will use a Pearson's correlation coefficient for variables that do not exhibit a linear relationship. So again, reminder, use only the Pearson's correlation coefficient if the relationship is better explained by a line. Okay? Second reminder, beware of unusual data points. The unusual data points, or sometimes we call them as outliers, can mislead the association, especially if the data set is small. If we look at the scatter plot of these two quantitative variables, we see that the points clustering on this region, okay, let's emphasize that, this one seems to form a positive linear relationship. So that is as x increases, Y increases. But as emphasized in this scatter plot, there is an outlier or an unusual data point. And what will be the effect of that outlier to our correlation coefficient? If we compute the correlation coefficient for the dataset with the outlier, it will be equal to 0.6479. So it will indicate it will indicate a strong positive linear relationship. While if we remove that outlier and we analyze our data again and compute the correlation coefficient, the value suddenly becomes equal to 0.9269. So it would now indicate a very strong linear relationship between the two quantitative variables. So I think very obvious explanation na po ito kung bakit kailangan nating tignan yung mga unusual data points or yung mga outliers sa dataset natin whenever we are trying to compute for the Pearson's correlation coefficient. Now, if you will ask me, although nakita ko din po ito sa comment section nung mga webinar series natin nung Monday and nung Wednesday, is it okay to remove these outliers? Babalik ko po sa inyo yung tanong. Okay? So if you will ask your statistician that question, the statistician will return that question to you. Because you will decide as the researcher if it's okay to remove or to omit that outlier. Okay? Kasi titignan natin yung magbabalance tayo ng trade-offs. Okay? Ano yung practical implication kapag tinanggal natin itong outlier na to? Baka kasi may informative insight itong pagtanggal natin or itong outlier na to, kaya mahirap siyang tanggalin. Okay? But of course, with a variety of tools in statistics, okay, marami po tayong tools that can detect outliers and at the same time handle the outliers in our analysis. Okay po? So, third reminder, beware of confounding variables. Okay? Ano pong meron doon? Because the relationship between two variables can be influenced by confounding variables. Confounding variables, unseen variables, lurking variables, pare-pares lang po yung ibig sabihin nun. Let's consider this example. On this scatter plot, we are examining the linear relationship between the number of hours spent on smartphone per day and the reading level of children. And via visual inspection, we see that as the number of hours spent on smartphone per day increases, the reading level also increases. Sounds weird, right? So pag mas matagal daw sa cellphone yung bata, mas tumataas daw yung reading level niya. Okay? Bakit kaya naging ganito yung na-form na linear relationship between the two quantitative variables? Now, if we separate the observations in this scatter plot and denote each point based on a specific subgroup, so we see here that the points colored as blue refer to observations collected from kinder students. Points colored as red refer to observations collected for grade 1 students. And yung green naman, collected siya for grade 2 students. Now, focusing on a specific subgroup, for example, dito tayo sa mga kinder, biglang nag-switch yung linear relationship na na-form natin kanina. This time, ano na po? Naging negative na siya. So, as the number of hours spent on smartphone per day increases, the reading level tends to decrease. And this statement is also true if we consider the points for grade 1 students and for grade 2 students. So, anong message natin dito? Katulad nga po ng sabi natin kanina, beware of confounding variables. Okay? So, itong confounding variables na to, it may be risky to combine information across subgroups that are not homogeneous. In our case, yung entire sample na na-consider natin, pwede pa pala natin silang ma-separate into different subgroups. Merong kinder, merong grade 1, and merong grade 2. And as we have seen from our illustration, the correlation coefficient or the linear relationship between the two variables can be switched or reversed if ever we will concentrate our insights on a specific subgroup. If you will look at certain references, okay, ito po yung tinatawag na spurious correlation, okay, correlation that is due to either coincidence or the presence of an unseen variable or what we call again as confounding variable. Okay? And the illustration po din natin, this is an example of the Simpson's paradox. So pwede po kayo mag-search sa YouTube or other references para mas maintindihan po natin kung ano yung Simpson's paradox na nabanggit ko. Alright? So, and the last reminder is that an unobserved relationship between two variables does not automatically imply that there is some cause and effect relationship between the two variables. Simply, correlation does not necessarily imply causation. Okay? Yes, it is possible that two variables that are related also have a causal link. But for you to establish that causal link or that cause and effect relationship, you need to control the other factors that can influence the variables under study. And don't worry, there are techniques in statistics that can help you achieve that objective. But the main message is, if you found that the two variables are linearly related, that's it. You do not say automatically that they have a cause and effect relationship. Hindi po Pearson's correlation coefficient yung makakasagot. No. Okay? If you're not yet convinced, let's have this example. In this scatter plot, we have two variables, height and salary. And based on the scatter plot, it forms a positive linear relationship. It forms a line that slopes upwards. So meaning, as your height increases, your salary increases. So para bang kung nag-establish ka ngayon ng cause and effect relationship, sasabihin mo sa research mo or sasabihin mo sa study mo na para tumaas yung sweldo mo, kailangan mo tumangkad. So, parang weird po yun, di ba? So again, yun ang nakita natin sa Pearson's correlation analysis. They have a positive linear relationship, but not necessarily a cause and effect relationship. All right? Okay. Now, of course, the correlation coefficient that we examined a while ago is based on a sample. Just like your other descriptive measures, yung mean, yung variance, yung proportion, we can compute it from the population and from the sample. If your correlation coefficient was computed based on observations collected from a sample, and you want to make inferences about this coefficient, you need to test hypothesis about the correlation coefficient. So ito hindi na po masyadong bago kasi na-discuss na po ni Professor Mananghaya nung way yung concept ng pag-test ng hypothesis. And the first step in testing your hypothesis is to formulate your null and alternative hypothesis. So in this case, our HO says that there is no linear relationship between X and Y, and your HA says that there is a linear relationship between X and Y. You can also say under HA that there is a positive linear relationship or there is a negative linear relationship between X and Y. It will now depend on you as the researcher on which hypothesis to test. Now, para lang po hindi kayo malito, tatandaan nyo lang po, di ba, diniscuss ni Professor Mananghaya nung Wednesday, our HO is a statement of equality. Tama po? At the same time, it can also tell that there is no effect, there is no difference, on the variables that we are examining. So simply, kung papapansin po ninyo, itong equality, no effect, no difference, di ba consistent po siya sa kung paano natin finormulate yung hypothesis for our correlation coefficient. No linear relationship. So yun lang po yung tatandaan nyo. Actually, basic concept yan eh. Para hindi kayo malito sa pag-formulate ng hypothesis, tatandaan nyo lang, HO is a statement of equality, statement of no effect, or statement of no difference or no change. Alright? So I hope na-recall natin yan from last Wednesday's webinar. But anyway, for the testing of hypothesis about our correlation coefficient, we will use the t-test. And as you have realized from our webinar last Wednesday, in performing certain statistical tests, there are assumptions that need to be satisfied. For this one, the assumptions of the t-test on the correlation coefficient are as follows. First, the samples are randomly selected. This is very important. Di ba po, diniscuss ni Professor Mananghaya that only randomly selected samples are valid for statistical inference. Second, X and Y are at least interval in scale. Again, this only means that your X and Y variables are quantitative. The first two, check naman po natin yan based on how we collected the data. But yung number three, the assumption of X and Y showing a bivariate normal distribution, of course, we need a statistical test for this. And one of the tests that you can use is the Dornick-Hansen test. Now, baka po alien sa atin yung idea ng bivariate normality. Okay? Balik po tayo sa discussion last Wednesday. Normality. Diba? Pag sinabi natin na yung variable ay normally distributed, it tends to exhibit a bell-shaped curve. Tama? So since dalawang variables na po yung pinag-uusapan natin dito, we will now plot our data values in a 3D plot. So such as what is flashed on the screen. So yung nakikita nyo pong GIF, okay, yan po yung illustration ng isang bivariate normal distribution. Alright. Now, that is the tool that you can use for computing or for examining the association between two quantitative variables. Okay? But how about if your variable is now measured in at least ordinal scale? O, review po ulit tayo. Anong ibig sabihin ng variable na nasa ordinal scale? Maalala po ba yon? A variable in the ordinal scale is simply a qualitative variable with implied rankings. Okay? But since our qualifier for this part of our discussion is at least ordinal scale, so we will consider variables that are ordinal in scale or quantitative. So scenario is, what if X is ordinal, Y is ordinal? X is ordinal or Y is quantitative? Okay? Or both X and Y are quantitative, but the assumption on bivariate normality was not satisfied. What will happen? Okay? So for this one, we have the Spearman's rank order correlation coefficient. Okay? And the Spearman's rank order correlation coefficient, as the name implies, will simply deal with the ranks. So simply, ang basic idea po ng Spearman's rank order correlation analysis is that you are performing the Pearson's correlation analysis using the ranks of your original data values. If you will look at statistics textbooks, yung Spearman's rank order correlation coefficient po involves the computation of the differences between the ranks assigned for X and Y. Okay? Now, very important that for you to know that for the Spearman's rank order correlation analysis, this is a measure of the monotonic association or relationship between two ranked variables. Recall from your basic math, pag sinabing monotonic, variables tend to move in the same direction but not necessarily at a constant rate. So for example, yung linear relationship, pwede natin siyang ma-consider as a form of a monotonic relationship. It moves in the same direction and at the same rate. Okay? But not all monotonic relationships are linear in form. You have to be aware of that. Okay? Now, some features, actually, ito po yung same features na nakita natin kanina. Range is still -1 to +1. Sign would still indicate the direction of the linear relationship. The magnitude will also tell if there is a perfect association or no association, or we can base it on the strength, ranging from very weak to very strong. Same pa din po, it will just tell us about the strength, but it will not necessarily inform us about the form of the linear relationship. Aside from that, it is still unitless and it is still symmetric. So again, bottom line is, yung Pearson's correlation coefficient saka itong Spearman's rank order correlation coefficient share the same features. All right. So some advantages of using the Spearman's rank order correlation coefficient. First, it does not always assume that the underlying relationship between x and y is linear. But beware, this doesn't tell you that you don't need to create a scatter plot. Okay? Remember, the scatter plot is still useful because it will tell you if a monotonic association exists between the two variables. Okay? Sorry. And the last one is that no assumptions of normality are made regarding the distributions of x and y. So as I mentioned a while ago, if the assumption of bivariate normality was violated, an alternative for your analysis of the two quantitative variables would be the Spearman's rank order correlation analysis. And for testing hypothesis about your Spearman's rank order correlation coefficient, we will still get the same set of HO and HA. So HO tells that there is no relationship, while HA tells that there is a positive, a negative, or there is a relationship between X and Y. For your test procedures, since yung Spearman's rank order correlation analysis is already classified under non-parametric tests procedures, we have two approaches. For small sample sizes, ang usual approach natin sa non-parametric tests, meron tayong mga coefficients. And yung mga coefficients na to, computed na siya before, we just have to simply refer to the table to generate our conclusions. While if you have large sample sizes, we can use the approximation using the standard normal distribution. Right? Don't worry, again, statistical softwares will already provide you with a p-value from which you will generate your conclusions. Alright, so let us now proceed with an example. Okay? Katulad nga po ng motivation natin kanina, since ang theme ng ating webinar ay tungkol sa pag-ibig. Okay? Let's examine this first scenario. Have you ever wondered why do so many couples look alike? Let's first watch this video.
Alright, nagkaroon lang muna tayo ng sandaling technical glitch siguro. Hintayin lang natin si Sir Enzo na bumalik yung kanyang connection. Nag-lag lang ng kaunti. Okay, so far sa ating comment section, madami po ang nagsasabi na linawan sila, na mas naiintindihan na nila ngayon. Very informative daw po ng ating webinar series. At kung may questions po kayo, just post nyo lang po yan sa ating comment section box. Mamaya po i-address po yan ng ating speaker. Ano po? And yung iba, sabi nila, naaalala nila yung kanilang advanced statistics, So, ayan, nakakatuwa naman. Ako po personally, gusto ko pong magpasalamat kay Sir Enzo kasi talagang mas na-appreciate ko po yung research ko po, yung thesis ko po dahil dun sa mga explanation niya sa Pearson's correlation. Sa sobrang dami po ng data na meron ako dun sa aking research. Ayan, si Mark Kevin Samson sabi niya, na ko lang na-realize may mali pala ako when performing Pearson's R. O, diba? At good morning din sa mga campuses na nakatutok sa atin, no? From PRMSU San Marcelino Campus, si Marjon Lagwatan. Ayan, good morning po sa inyo. And, ayan, good morning kay Alexis Certifico Arsena. Ayan, good morning. Sa mga nakatutok, nakita ko ang daming, literally from all over the Philippines po yung nakatutok sa atin. So, just keep on watching po para mas matuto tayo at mas ma-appreciate po natin yung statistics. Okay? Very impressive daw po. Blessed morning kay Evelyn Alera watching from Bulacan College. Ayan, good morning din kay Venus Buscas Martinez, kay JM De Loreto, Ruben Ismael Ganapin, Renalyn Abellano sa Apostol, Edward David, Tera Cruz de la Cruz. Ayan, good morning po sa inyong lahat. Alright, so mag-comment lang po kayo dyan. Andyan pa rin po ba kayo? Mag-comment po kayo na nakatutok pa rin po kayo kasi hindi pa po tapos yung ating ating webinar series. Magbabalik po si Sir Enzo for sure. Okay, ayan. I think nandyan na siya. Let's just allow him to prepare lang sandali. No? Medyo mabigat yung video kasi alam niyo naman, we have to depend on our internet connection. We have to do what ano tawag ito? Pagtiyagaan kung anong meron tayo. Ano? What else? Ayan, shout out po sa mga taga Bulacan, taga Palawan, ayan, taga Ifugao State University, ayan, shout out po sa inyong lahat. Okay, let's please welcome back sa Zoom space, Sir Enzo.
Yan, I'm very sorry po. Yan, nananawagan po ako sa mga viewers po natin from PLDT. Bakit po kaya biglang nawalan kami ng internet? Anyway, so resume po natin yung video natin with restart po nung video natin. Alright. Alright. So, taas kamay po dito, okay, na yung mga married or in a relationship na sinasabi ng mga friends nyo or ng family members nyo na magkamukha daw po kayo. Yan. So, ang isang explanation po na nakita natin from this video ay yung nakita natin. Or kung hindi naman po kayo in a relationship, okay, pero kung kayo ay nakikipag-date, yan. So, let's consider this example. So, same height couples. A sociologist wonders whether people of similar heights tend to date each other. She randomly selected 10 of her office mates who are exclusively dating and asked them the height of the person he or she currently dates. All right. Now, let's first examine the relationship of these two variables using a scatter plot. So once again, based on our problem, we are considering two quantitative variables. The first one is the height of a person, yung office mate, yung sociologist, and the other variable is the height of the person that his or her office mate dates. Okay? And based from this scatter plot, we are seeing that there seems to be a positive linear relationship between the two variables. So as your height increases, yung dinedate mong tao, yung height niya also tends to increase. Okay? Now let's verify that statement using our correlation coefficient that we would expect to be positive. Okay? Now since we are considering two quantitative variables, candidate para doon sa ating correlation coefficient is the Pearson's correlation coefficient. And using our commander, we will see here that the correlation between the two heights is displayed on this portion of the statistical software output. So it's equal to 0.5477104. And based from this value, we say that there is a moderate positive linear relationship between the heights of couples. Okay? But then again, since this value was obtained from a sample, and say we wish to make conclusions or statements about the population of all couples, let us perform a test of hypothesis. And using the test of hypothesis, that is the t-test on our correlation coefficient, we first need to check the assumptions. And the very important assumption of the t-test on the Pearson's correlation coefficient is that the x and the y variables should exhibit bivariate normality. Now, based on our R commander output, we see that the p-value is equal to 0.2271692. And recall po sa discussion ni Professor Mananghaya last Wednesday, di ba po yung decision rule natin is to reject HO if the p-value is less than or equal to alpha. Otherwise, fail to reject HO. But new developments in statistics or developments in statistics would actually also encourage us to adopt this decision rule. That is to reject HO if p-value is too small. Otherwise, fail to reject HO. Okay? Now again, yung issue kung ano yung too small, again, it is discipline specific. Okay? But anyway, since this p-value is relatively large, our decision is to fail to reject HO, and thus the assumption of bivariate normality is satisfied. So since the assumption was satisfied, let's proceed with the testing of hypothesis using the t-test. And what would be our HO and HA? HO, there's no linear relationship between the heights of couples, versus HA, there is a linear relationship between the heights of couples. Now, using our commander, we would generate the following output for the t-test on our correlation coefficient. P-value is equal to 0.1012. So again, this p-value is relatively large. Okay? So whether you set your alpha to 0.05, 0.01, or 0.1, your decision would still be to fail to reject HO. So since you failed to reject HO, your conclusion would be there is no sufficient evidence that there is a linear relationship between the heights of couples. Alright? So again, babalik po ulit tayo dun sa mga reminders natin kanina. Wala tayong in-establish po dito na cause and effect relationship. Ang malinaw lang sa atin, there's no sufficient evidence of a linear relationship between the two variables. Alright? Now, in another example, let us now consider the problem of interjudge reliability. So to be fair as possible, competitions have more than one judge for an event. A cooking contest have two judges, tasting each of the 10 dishes and ranking it according to preference. It is of interest to determine the consistency between the rankings of the judges. Now, based on our problem, take note, we are now considering rankings. And we know by nature that ranking is an ordinal variable, right? So since our variable of interest or variables of interest are ordinal in scale, we cannot use the Pearson's correlation analysis a while ago, right? But if we inspect the scatter plot, again, it tends to form a positive linear relationship or positive relationship. That is, as the ranking of Judge A increases, the ranking of Judge B also increases. And since both are ordinal variables, recall po sa discussion natin kanina, okay, the appropriate tool to use is what? The Spearman's correlation analysis. So using our commander, we would see that the Spearman's correlation coefficient is 0.9272727. And this indicates that, based on the sample, there is a very strong positive association between the rankings of the two judges. That is, as the ranking of Judge A increases, the ranking of Judge B also tends to increase. Okay? For testing hypothesis about this coefficient, we'll still adopt the same format for your H2 and HA. HO, there is no association between the rankings of the two judges, versus HA, there is an association between the rankings of the two judges. Looking at our R commander output, yung p-value po natin this time is 0.0001. Now, if we are based on our decision rule, this is too small. Whether we use our alpha to be 0.05, 0.01, or 0.1, our decision will be to reject our null hypothesis. And what does it tell us? There is a sufficient evidence that there is an association between the rankings of the two judges. All right. Now, before I proceed with the next topic, allow me to answer some of the questions in the comment section. First question is from Mr. Del Loreto. Sabi niya, tama po ba narinig ko na kailangan interval ang data before you can use Pearson R? How can we reconcile po ito with the new research saying na pwede po, hindi na to verbatim pwede po yung Pearson's R sa ordinal data? Okay? Now, here's my take on that. Kung babalik po tayo sa levels of measurement, okay, yung quantitative variable, equally spaced po yun. Tama? For example, kung height in inches, yung 1 inch versus 2 inch, alam mo na ang difference, 2 inches, alam mo na yung difference nila is 1 inch. So weights, for example, yung 69 kilograms sa 70 kilograms, alam natin na 1 kilogram yung difference nila. Tama? But for scales, for variables in the ordinal scale, pag sinabi ko bang rank 1 versus rank 2 versus rank 3, o kaya yung mga satisfaction ratings natin na 1, 2, 3, 4, 5, sure po ba tayo na equally spaced lahat ng yun? If you are confident and that these levels are equally spaced, then, sabi nyo nga po, developments in statistical researches would say that you can use Pearson's R. So sa part na yon, hindi po ako makikipag-argue because you can justify that the variables or the levels of the variables are equally spaced. Clear po ba yung sagot ko, sir? So I hope na-clear natin sa atin po yun, ha? Kasi I'm sure yung iba po sa inyo, nakakakita ng mga researches na nag-a-apply ng Pearson's R sa mga ranked, sa mga ordered variables. Okay? Again, pag may kausap po akong client, tas yun yung preferred na analysis nila, sasabihin ko sa kanila, kaya nyo po bang ma-justify na equally spaced yung levels? Okay? If so, we can proceed. If not, sabi ko nga po, meron naman tayong Spearman's rank order correlation coefficient. Okay? Please tell me na lang po, sir, ha, if na-clarify ko po yung sagot or yung tanong po ninyo. Alright? So, very quick lang po. Check natin if there are other questions bago tayo mag-proceed doon sa next measure of association. Alright. Sige po. Now, moving on, let us now explore the measures of association for count data. And ano po ba yung count data? Simply, count data arises from qualitative variables. As the name implies, count, this indicates the number of times that some event of interest has occurred. And for the analysis of count data, you can have a one-way contingency table or a one-way classification table and a two-way classification table, or sometimes called as a contingency table. For the analysis of count data, we would usually expect the chi-square tests to achieve or to answer this objective. So, ang basic idea ng chi-square tests, if you will recall from your basic statistics, we have the observed counts and the expected counts under the null hypothesis. Observed counts, as the name implies, how many of the items or subjects fall into each category or set. So yung actual observations natin. While the expected counts would inform us how many of the items or subjects would we expect to see if the null hypothesis is true. So in chi-square tests, our null hypothesis would tell us how our variable or variables of interest are distributed across our population. For measuring association, we have the chi-square test of independence. And this actually results from a contingency table. So the chi-square test of independence would tell us if two qualitative variables are associated. In another term, it can tell us whether the category that an item or subject falls in for one variable depends on the category they are in for the other variable. Now, here are some of the assumptions. Number one, di pa siya nawawala, samples are randomly selected. Two, all expected frequencies are at least one. And three, at most 20% of the expected frequencies are less than 5. Now, you will see, medyo demanding sa manual computations yung pag-check ng assumptions ng chi-square test. Kasi kailangan po nating i-check yung expected frequencies. But don't worry, again, statistical softwares will provide you the expected frequencies for your data. For our test of hypothesis, we have the similar set. HO, row variable, is not associated with the column variable. HA, row variable, is associated with the column variable. Now, from your test of hypothesis, you will come up with a chi-square test statistic that you will use to generate conclusions about your population. And this time, we will use this chi-square test statistic to inform us about the strength of the association between our variables. Okay? Two of the most commonly used chi-square based measures of association are the Pearson's phi coefficient and the Kramer's phi. And we will adopt the following rule to interpret the strength of the association between the two qualitative variables. Now, a very important remark for this one is that notice that your chi-square based measures of association tells you about the strength of the association. So meaning, you first need to know that the two variables are associated. So on the previous test of hypothesis, wherein you are checking if the row variable is associated with the column variable, and from your test of hypothesis, you found that there is sufficient evidence that the two variables are associated, then you can determine the strength of their association. All right? Now, in case wherein the assumptions of the chi-square test was not satisfied, we have an alternative and that is the Fisher's exact test. Okay? The Fisher's exact test is used when the sample size is small, and most especially, this can be used for responses that are dichotomous. So meaning, yung row variable, as we can see from this table, two possible values lang. Yung column variable, two possible values lang. So basically, meron po tayong 2 by 2 table. Okay? Now, in some cases, wherein your qualitative variable has some order or has an implied ranking, sometimes the use of the chi-square test would not inform us about the ordinality of our variable. So ang big idea po kasi, yung chi-square test, it tends to ignore the ordinality of our variables under study. So in this case, sometimes the chi-square test has less power than the other tests that are appropriate for ordinal variables. So kung ordinal by ordinal yung meron tayo, tapos nag-result yon sa isang count data, we can perform the linear trend test. And ano po ba yung idea ng linear trend test? It simply answers this question. As the level of the row variable increases, do the column variable responses tend to move towards higher or lower levels? Ang basic idea po ng linear trend test, parang tinitrick niya yung test na diniscuss natin kanina na instead of using the exact levels, nag-a-assign po tayo ng scores. So, halimbawa kung ordinal siya, say ranging from very satisfied to very unsatisfied, mag-a-assign po tayo ng scores sa bawat level. And yung pag-assign ng scores, marami pong approaches yon. So, pwedeng equally distant sila, pwedeng based on your subjective preference, or pwedeng mag-assign lang tayo ng mga mid-rankings. Okay? There are several approaches on how to do it. Okay? Now, you might ask me, ordinal by ordinal. Di ba pwede naman po yung Spearman? Yes. Okay? But sometimes, if there are too many tied ranks, nagkakaroon po tayo ng problem sa computation for Spearman's rank order correlation coefficient. So an alternative would be to perform a linear trend test, and our test procedure for this is the Mantel-Haenszel test. Okay? So the Mantel-Haenszel test is another statistical tool that you can use to check if there's an association between two ordinal variables. An improvement of the Mantel-Haenszel test can also be used for determining the association between an ordinal variable and a nominal variable with only two categories. Now again, big idea lang po ng linear trend test at ng Mantel-Haenszel test. We are just getting the correlation between the scores assigned to each level of your row and column variables. Okay, now based on the Mantel-Haenszel test and other linear trend tests that we have, we can again come up with measures that would inform us about the strength of the association between these two ordinal variables. So we have the pre-based measures. So pre stands for proportional reduction in error. And what does it tell us? How much error can be reduced in predicting one variable by knowing the value of another variable. So of course, since error po ang pinag-uusapan natin, di ba? Mas gusto natin na mas malaki yung error na kayang ma-reduce in predicting one variable based on the other variable. Okay? One of the commonly used pre-based measure of association is the Goodman and Kruskal gamma used for ordinal variables. All right. Let's proceed with an example. Yan. So, topic pa din natin tungkol sa pag-ibig. Yan. Sino na po ang nasaktan? Yan. Ano nga po yung ano nila doon, pick-up line? Yan. Nasaktan pero bumangon ulit. Yan. Pero yung example natin, tungkol sa pain, pero hindi tungkol sa pag-ibig. Yan. Pain assessment. So let's again watch this video.
Pain is manifested in a change of physical, emotional, and behavioral traits. Facial expressions are the most specific encodable form of pain behavior in humans, as well as being accessible and highly plastic. PainCheck uses computer vision algorithms called convolutional and deep neural networks to detect facial expression features and characteristics most consistent with acute and chronic pain. The networks are trained through a mathematical process of machine learning. This automatically tunes the PainCheck algorithm parameters to recognize target data in a most accurate way. People living with dementia and those with cognitive impairment lose their learned pain behaviors and express pain more intensely. The PainCheck adult algorithm has been fine-tuned to identify facial pain-related micro-expressions in these groups of people. Image-captured objects share common features. PainCheck is reapplying this trained network knowledge to different target groups with a much faster learning curve. PainCheck Kids is being developed to detect pain in babies and toddlers through face and cry analysis. In the future, PainCheck could continuously monitor pain in the general adult population, in patient waiting rooms, vehicles, or the home environment. PainCheck's machine learning processes is continually improving. Pain-related facial expressions imagery are fed back into the training process for greater accuracy. Mining data about people in pain can help identify particular pain markers or pain signatures to help healthcare professionals and caregivers provide better treatment. Together with unsupervised learning, algorithms for automatic deductions of patterns in data, it can strengthen and improve the pain detection and ongoing monitoring process. With continuous development and improved hardware capabilities, PainCheck AI will become a world-leading expert in facial pain analysis and pain behavioral pattern recognition.
All right, so let's consider this example, a pain expression. Patients with dementia do not always give a verbal indication that they are in pain. A researcher examined the relationship between a nurse's assessment of a patient's facial expression and his or her self-reported level of pain. Data were collected from 89 patients in a certain hospital. Is there evidence to believe that there is a relationship between a facial expression that reflects pain and self-reported pain? Okay? Now, in our problem, we are considering two qualitative variables. Self-reported pain. So, possible values po niya, pain, no pain. Okay? And the assessed pain. Okay? Again, possible values niya, pain, no pain. Okay? Now, for our hypothesis to be tested, same idea, HO tells us that there is no association between the facial expression and self-reported pain of patients with dementia. And the other hypothesis, our HA, will tell us that there is an association between the facial expression and self-reported pain of patients with dementia. Now again, we first need to check the assumptions of our chi-square test. And sabi po kanina, dapat lahat ng expected counts natin ay at least 1. And no more than 20% of our expected counts are less than 5. And based on the R commander output, we will check expected count po ng no pain is 12.809, greater than 1, greater than 5. Ito po, greater than 5, greater than 1 din, this one, and this one. So, nasatisfy lahat ng expected counts. So, based on this, all expected counts are at least 5. So, hence, we can proceed with the chi-square test. Okay? Now, quick question. Sir, paano po kapag hindi na-satisfy? Okay? A usual approach is to combine certain categories. So, syempre, hindi siya magiging effective dito sa example natin kasi 2 by 2 lang to. Okay? But if you have more than 2 rows and more than 2 columns, tapos hindi na satisfy yung assumption sa expected frequencies, you can combine rows and columns. Okay? So, depende na po yun sa inyo. Yung researcher na yung magde-decide kung okay lang na may mga rows and columns na i-combine. Okay? Again, kung hindi pa rin na-satisfy, kasi nangyayari naman po itong scenario na to, especially if you have small samples. Sabi nga po natin kanina, kung 2 by 2 naman yung table mo, you can use the Fisher's exact test. Okay? Now, based from the R commander output, we found that the p-value is equal to 0.02656. Okay? Now, this value is relatively small, so we can reject our HO. Okay? So, sabihin na natin, pwede natin iset yung alpha to 5% or 0.05, we will still reject the null hypothesis. Okay? And this tells us that there is sufficient evidence that there is an association between the facial expression and self-reported pain of patients with dementia. So, there is an association. The next question is, how strong is the association? So we can compute for a chi-square based measure of association. And for this one, we use the phi coefficient. So the phi coefficient has a value equal to 0.2351, which indicates that there is a moderate association between the facial expression and self-reported pain of patients with dementia. All right. So, before we proceed with our break, allow me to share just some of the other measures of association that you can use depending on the nature of your variable. First is the point biserial correlation. When to use this? You will use this when X is dichotomous, meaning two possible values but without natural ordering, and your Y is quantitative. Example, smoking status, that's dichotomous, and there's also no ordering for this variable. Smoking status, smoker, non-smoker. Okay? And the other variable is resting heart rate. That is quantitative if measured in beats per minute. So if you have the similar set of variables, you can use the point biserial correlation. The other tool is the biserial correlation. Ano naman po yung point nito? Ang difference now with point biserial correlation is that your dichotomous variable now has a natural ordering. Example, weight. If you classify now weight as light and heavy, instead of reporting it or collecting it quantitatively, and the other is average daily expenditure on fast food, measured in pesos. Next, we have the tetrachoric correlation. When to use this? If your X and Y have been dichotomized and it has a natural ordering. So, you'll notice in our example, selling cost and floor area are quantitative by default. Tama? Selling cost, pwede natin siyang i-measure by default in pesos. Floor area by default in square meters. But depending on your study, depending on your data collection plan, you can instead decide to just collect it or observe it by classifying the selling cost as low and high and the floor area as small and large. So if you have the similar scenario and you want to determine if these two variables are related, you can use the tetrachoric correlation. Next is the eta correlation. When to use this? If your X is qualitative and you have information that X is a predictor or an independent variable, while your Y is quantitative and again you have an information that it is the response or the dependent variable. Now example, say you want to study the number of years in service of an employee and its relationship with job satisfaction. Years in service, say for your study, you consider this as your response or your dependent variable. And you think that job satisfaction influences this variable. So yung job satisfaction natin dito, ito yung independent variable. And looking at job satisfaction, it has two possible values, satisfied, not satisfied. So if you have the similar set of variables in your study and you want to determine if they are related, you can use the eta correlation. All right, so that's it for now. Okay, so we are done with the correlation analysis. I hope you were able to now quickly identify what appropriate tool should be used given the nature of the variable and of course, given your objective. So katulad po ng sinabi ni Ma'am Cheryl kanina, okay, kailangan po muna nating mag-regenerate ng brain cells natin. So, namimiss nyo na po bang mag-video, okay? Sabi nga po sa video, okay, are you having fun? Yan. So, this point, break po muna tayo or I will turn over the Zoom space to Ma'am Cheryl. Ma'am Cheryl.
Thank you so much, Sir Enzo. Ayan. Guys, andyan pa ba kayo? Kaya pa? Sige nga, mag-comment ng strong sa comment section box kung gising na gising pa rin kayo at kasama pa rin po namin kayo sa aming session. Okay? So far, kamusta po kayo guys? Let us know. Just comment strong sa comment section box. Strong ba ang correlation? Positive ba? Negative? Okay? Si Sarah, sabi niya, sir, na-appreciate niya daw po yung wits po ninyo sa statistics. Mas lalo kong naintindihan, sir. Salute daw po kay Sir Enzo. Wow, that's great. Kasi Ariel naman daw, very clearly explained. Kudos to the speaker. So, ayan. Thank you so much sa nice comment, ano? Si Francisco Naldosa naman daw, sir, nasaktan, naging single, ngayon nag-one stat at a time. Sana makapag-move forward ka talaga, ano, using this webinar series. Alright, dahil dyan, break po muna tayo. Pwede rin mag-CR break, mag-unat-unat ng kaunti, uminom ng tubig, o kaya magkape, para mas lalong alert sa pagpapatuloy ng ating session later. Okay? In the meantime, let's watch a video still about UP Los Baños po, ano. As you may already know, we are located at the foot of Mount Makiling. And let's see why the municipality of Los Baños, Laguna was declared as a special science and nature city of the Philippines. Let's all watch this.
Legend tells of a mysterious and beautiful goddess who dwells within the forest of Mount Makiling. Known as Maria Makiling, she supposedly guards the mountain and the forests. Myths depict her as a benevolent nature spirit, gifting communities with nature's bounty. While the reality of Maria Makiling's existence has never been proven, Mount Makiling itself, its majestic beauty, and the rich bounty of resources and environmental services that it has provided is real. First established as a protected area in 1910, the Mount Makiling Forest Reserve has been under the care of UPLB since 1960. It covers an area of over 4,000 hectares and was declared an ASEAN Heritage Park in 2013. Mount Makiling boasts of an impressive diversity of flora and fauna, endemic, native, and introduced. Mount Makiling functions as both laboratory for forestry students and a tree nursery as UPLB leads efforts to study and preserve endangered tree species. It is a popular ecotourism destination that helps promote appreciation for nature and the need to preserve it. Popular sites in Mount Makiling include the Makiling Botanic Garden with its rich collection of tropical plants, the sulfuric mud springs, Pictou, and flat rocks. Aside from taking up the role of steward, UPLB has kept Maria Makiling alive by making her a part of the community's culture and arts. Stories of the forest goddess are a popular theme for the many cultural activities that take place in UPLB, such as theater productions, folk dance presentations, and art exhibits. The richness of culture and the arts in the university is expressed through many different art forms. These varying art forms serve as a reflection of the rich tapestry of culture and traditions of UPLB. Regardless of whether it is the mountain or the maiden, Mount Makiling has always been the stalwart and benevolent guardian and icon of UPLB. Throughout UPLB's long history, Mount Makiling has sheltered the community, served as a source of inspiration and wonder as UPLB continues its pursuit to preserve the environment, celebrate Filipino culture, and contribute to the country's growth and prosperity.
Alright, there you have it guys. Miss na miss na ba ang LB? Well, miss ka rin daw niya. Okay? In time, magkikita-kita rin po tayo, no? Sabi nga nila, kapag naranasan ko daw yung LB life, pati LB nights, babalik-balikan mo talaga yung ganda niya and most of the time, ayaw mo na siyang iwan. Okay? Alright, so sa mga nag-comment sa atin ang strong, ayan, talagang very creative kayo sa inyong pag-comment, no? Merong stronger, strong, alive, and kicking. Di ba? Strong and ano pa ba yung nakalagay doon? Stronger, napaka-lalim yata ng mga hugot. They're very strong and nakatutok pa rin daw talaga sila sa ating webinar series. Okay, now let's have an icebreaker para sabi nga ni Sir Enzo, di ba, ma-energized, ma-regenerate ang ating brain cells dahil napakadami nating diniscuss na statistical tools, no? Mamaya dadagdagan pa ni Sir Enzo. May we kindly direct your attention once again to menti.com, which is, by the way, we learned from Sir Enzo himself. No? Simula nung malaman po namin siya, the rest is history. Lagi na po namin siyang ginagamit. Okay? Use the code 2647900. There are 2 questions there po. Let me also post the link sa ating Facebook Live para po makasunod yung mga ngayon pa lamang ulit susubok ng ating menti.com. Para diretso na po kayo doon sa site mismo. Okay? So there, actually one question lang po yun, no? Ang ating question, let me just share my screen so we could see the live results. Okay. Ang question po natin dyan, ang talaga namang problema ng lahat, procrastination. Which type of procrastinator are you? Are you the perfectionist, the dreamer, the avoider, the crisis maker, the busy procrastinator, or lahat po? Ma'am, parang ako lahat yan. Ano ba yung perfectionist? Ito daw yung mga taong gusto perfect lahat, nag-iintay ng perfect timing or perfect approach, only to end up completing nothing at all. Kasi nga, masyado siyang perfectionist, iniintay niya yung right timing. Well, the dreamer, ito daw yung mga taong madaming gustong gawin. They have big, ambitious plans, pero hanggang doon lang sa pangarap, ayaw gawing realidad. Kaya naman, ayaw nila ng hassle, ng stress. So in short, ayaw mahirapan. So doon lang sila sa dreaming stage. Well, the third one, the avoider, of course, from the word, itong type daw ng person na ito ay fears, failures, and mistakes. They're also called the warrior and the self-saboteur. Ang mantra nila, by doing nothing, bad things won't happen as well. Okay? The fourth one, maraming makaka-relate dito, the crisis maker. They are also called the daredevils. Ang mga linyahan nito, mga linyahan natin, umaamin po ako, mas productive ako pag last minute na ng deadline. Hanggat wala pa ang deadline, hindi pa gagawa. Ang tawag daw po dyan, crisis maker. And the last one, busy procrastinator. Ito po yung grabe mag-overwhelm. Sa isip nila, ang dami na nilang kabisihan, overwhelmed sila, so hindi nila alam kung ano yung unang tatapusin. So, at the end of the day, dami kong gagawin, pero hindi pa rin niya tinapos. Okay? So, alin ka kaya dyan sa 5 yan? If you are a follower of LRC page, yan po yung mga talagang nag-trending sa aming page, ano, yung procrastination, because we all are, sino bang hindi nagpo-procrastinate? Lahat naman siguro nag-procrastinate, but ako po personally, I've learned something during the pandemic, which is, yun nga, one step at a time, little by little, tapusin mo siya. Hindi mo na mamalayan, wow, na-accomplish mo na pala lahat siya. Okay? So, ayan. So far, magkapantay po ang the perfectionist at lahat po. Lahat daw po siya yun. It's very important daw po to address the procrastination is that you determine kung ano yung triggers mo, ano yung nagko-cause ng procrastination mo, and then you address it. Okay? Ayan, lahat dumadami na. 37 na yung lahat po. The perfectionist, 34. Next is the busy procrastinator. Talaga ba? 7 lang yung crisis maker? Talaga ba? Dun sa Facebook page kasi namin puro crisis maker daw po eh. Ako po ay hybrid. A hybrid of the perfectionist and the crisis maker. Naamin ko po yan. Okay? If you want to know how to address this, if you are also experiencing procrastination, if you want to address these things, pwede nyo pong puntahan yung LRC page. You might see something helpful for you there. May mga tips po tayo dyan. Okay? So, salamat po sa 152 na sumagot. I hope may natutunan kayo dito sa menti.com na ito, no? Alright. So, thank you so much for answering. And I hope na-energize tayo ng husto sa ating icebreaker, no? Sabi nga, if you want to change a habit, it can't be done overnight kasi habit na siya. But we can do it little by little, day by day, and one step at a time. All right? So I guess that's enough for the icebreaker. Let's now go to the second part of our session. Let's please welcome back our speaker to the Zoom space, Sir Enzo. Sir Enzo, please take it away.
Yeah. Thank you, Ma'am Cheryl. Yan. Idol ko talaga yan si Ma'am Cheryl dyan sa mga pa-segue na yan. O diba na i-link ni Ma'am yung one step at a time natin. Anyway, so welcome back to the second part of our webinar. And this time, we'll talk about the regression analysis. So brief recap lang po, sa correlation analysis, our interest is to determine if there is a relationship between two variables. And we have examined several tools that you can use depending on the type of the variable. For example, nakita po natin kanina, if we have nominal by nominal, pwede daw natin gamitin chi-square test. If you have quantitative versus quantitative, pwedeng Pearson's, pwedeng Spearman, depende kung na-satisfy yung mga assumptions. Okay? But in reality, sometimes you would not just stop in determining if there is indeed a relationship between the two variables. We want to come up with a function that can describe the relationship between these two. And let's talk about the regression analysis, and we'll start with the simple linear regression when there is only one predictor and y is quantitative. All right, now, for the simple linear regression analysis, all you need to remember is the idea of the scatter plot a while ago. Diba? Sa scatter plot kanina, yung points nagka-cluster sa isang space, and there is an imaginary line. Okay? And that straight line is our basis for performing the simple linear regression analysis. Okay? So in simple linear regression analysis, our goal is to find a straight line that fits the data. And our goal is that this line should minimize the distances between the points. So this line should come as close as possible to all the points in our data. And in simple linear regression, please take note that this time, the x and the y will now have distinct roles. So kanina po sa correlation, sabi natin, it doesn't matter which variable will be assigned as x or which variable will be assigned as y. But this time, for the regression analysis, it's very important for you to know that y is now our response or dependent variable, and our x is now the independent or the predictor or the explanatory variable. Okay? So again, for us to understand the idea of the simple linear regression, let's recall the equation of a line. From your basic math, you know that the equation of a line is expressed as y equals a plus bx. Sige, Crash course tayo sa basic math. Oh, y equals a plus bx. Di ba po, recall natin, yung b is called as the slope. And how do we interpret the slope? Naalala ko lagi, sasabihin ng students ko, how do you interpret the slope? Sasabihin nila, rise over run. Other interpretations, yung practical interpretation, yung maiintindihan ng kahit hindi knowledgeable masyado sa stat. Diba? Yung slope, recall, in math, we interpret it as the amount of change in y when x is increased by 1 unit. Tama po? While a, we call that as your y-intercept, and we interpret y-intercept as the value of y when x is set equal to 0. So, now that you have recalled the equation of a line, now, let's consider an example to exhibit this line that we are talking about. So, success in college. The director of the Office of Admissions at a local college would like to predict the general weighted average of students upon graduation based on their college admission test score. Random sample of 20 students who had completed the program was selected. Now, if we are to visualize the relationship between the two variables collected in our data, we have the college admission test score and the general weighted average. You would notice that is a what? Decreasing relationship. So negative relationship. So that is if your college admission test score, your general weighted average tends to decrease. Pero wag po tayong ma-confuse, okay? We all know that in most colleges, yung excellent na grade is near 1. Tama? While yung mga poor performing na mga students, yung GWA nila is near 5. So kung practical interpretation po yung pag-uusapan natin dito, okay, pwede nating sabihin na as your college admission test score increases, your GWA, quote-unquote, increases. Kung gagamitin natin, kung ang kino-consider nating basis ng grade ay yung from 1 to 5, na yung 1 po yung mataas, tapos yung 5 po yung mababa. So wag tayong ma-confuse ha, kaya po ganito yung na-form natin na relationship between these two variables. Okay? Now, kung makita po natin from this scatter plot, okay, we can perform a Pearson's correlation analysis by just simply computing a coefficient. And based on our coefficient, which is negative 0.89, this one, based on our R commander output, we say that there is a very strong negative linear relationship between college admission test score and GWA. Then again, let's go back to the objective. What if you want to predict the GWA based on the college admission test score? So earlier, we found that the scatter plot forms a straight line that slopes downwards. Okay? And ang basic idea po ulit ng regression analysis ay ano itong line na to? Okay? We will find that line that best describes or summarizes the relationship between the two variables under study. Okay? Now, emphasize ko po itong point na to. 85.0 saka 1.1. So the college admission test score is 85. The general weighted average is 1.1. You will notice this certain point did not lie exactly on the line. Tama? In fact, sabi nung line, if your college admission test score is 85, your GWA would be somewhere near 1.5. Bitin ko po yan ha, para maintindihan natin yung concept ng regression. This is the actual observation, 85, 1.1. We found in the scatter plot that there seems to be a line that summarizes the relationship. Again, sa regression, hahanapin ko tong line na to. Ano yung equation ng line na yan? And if you notice, based on this line, if your college admission test score is 85, you would notice that your general weighted average is predicted to be near 1.5. Paano po kaya yon? Ano yung effect nun? notice that may difference yung predicted doon sa actual na na-observe natin. Na? Sa pa pong example, a college admission test score, say this is somewhere 70, okay? Ang expected na GWA is near 2.0. Pero kung i-base po natin sa line, medyo mas mababa pa doon. So merong difference, merong deviation yung observation natin with what can the line provide us. So for a clearer illustration, okay, palakingin po natin yung space para mas makita natin yung effect. Let's just consider 2 points. This one and this one. This represents observation when x is equal to x sub 1. This represents the observation when x is equal to x2. And ito po, yung line natin that would best describe the relationship between the two variables. Now, in regression, we would expect that the actual observed data would differ from what can the line provide us. Ito po yun. And if you notice, we label them as epsilon. So ano po ba yung epsilon? In regression, we call them as the residuals. So the residual is simply the difference between the observed response and the predicted response. And how do we use this idea for our regression analysis? Basically, our goal is to make all the residuals as small as possible. And an approach to this is by using the least squares regression line. That is a line that makes the sum of the squared vertical deviations of the data points from the line as small as possible. So the least squares regression line is defined by this equation. Y is equal to beta 0 plus beta 1x plus epsilon. Again po, itong epsilon na to, ito po yung residual natin. Okay? Now, again, as you may have noticed from our previous discussions, beta 0, beta 1, pag gumagamit tayo ng Greek letters sa statistics, usually, ito po ay mga measures na galing sa population. So, if you have the sample data, then we also have the sample linear regression equation. So let's consider this estimated regression line for the simple linear regression. That is y hat I equal to b0 plus b1 xi. Now, what does this items tell us? Simple lang po. Recall again, equation of a line, y is equal to a plus bx. Tama po ba yun? So that means your b0 is your a, your b1 is your b. So, your B0 is your y-intercept or your estimated regression constant, and your B1 is your estimated regression coefficient or the slope, which is again the amount of change in y when x is increased by 1 unit. Now, before we proceed with the actual computations or actual formation of the linear regression equation, let's first check the assumptions of the simple linear regression analysis. First, the linear model is reasonable. As the name implies, linear regression. So a linear pattern should best describe the relationship between the two variables. How to check? One approach, construct a scatter plot. Yung kanina pa po natin ginagawa. The points in the plot for your x and y variables should exhibit a linear pattern. Another approach is to construct a scatter plot of the residuals versus the predicted values of y. Pwede rin pong residuals versus x. And we say that a linear model is reasonable if the points in the plot exhibit a random pattern. Assumption number 2, the error terms are independent. How do we go about this? The lack of independence usually occurs when your data is collected over time or over a certain order. So in this case, one way to check if the error terms are independent, you simply plot the residuals versus the order of observations. And the error terms are said to be independent if the plot shows a random scatter of points with no apparent pattern. There's another way to do it. Okay? But before that, check natin ano po ba yung magiging difference kung yung errors ay independent at errors are not independent based on the residual versus order plot. You can see here, in this plot, the points are randomly scattered. While the plot on the right shows that as your observation order increases, the residuals tend to increase as well. So you can say that somehow, as the observation order increases, say yung time, halimbawa po, as time increases, yung responses mo for the Y tends to also increase. Now, in this case, this is a clear violation of the assumption on the independence of errors. Okay? Now, other than visual inspection, you can also check if the errors are independent by using a test of hypothesis, and that is the Durbin-Watson test. Third assumption, the errors are approximately normally distributed, okay, or are normally distributed. How to check this? The simplest way is to construct a histogram of the residuals. And recall, if your errors are normally distributed, the histogram should exhibit a bell-shaped curve with no outliers. Another approach, construct a quantile-quantile plot, or what we call as QQ plot, of the residuals. In the QQ plot, you say that the errors are normally distributed if the points in that certain plot lie close to a straight line. Let's have an illustration. So again, we have the QQ plot as an alternative for checking the assumption of normality. Plotting the residuals in a QQ plot, we see in the plot on the left that the points lie close to this straight line. So we say that the errors are normally distributed. Well, on the other hand, the plot on the right shows that the points tend to follow a curvilinear pattern. Tama? Some points, for example, these points are very distant to that straight line. So in that case, we say that the assumption of the normality of the errors is violated. And another way to check it, pwede rin naman po, alternative natin is to just perform a test of hypothesis. And recall po from the discussion of Professor Mananghaya, one approach to check the assumption of normality is the Shapiro-Wilk normality test. Okay? Assumption number 4, the error terms have a zero mean. And this is very easy to check. Recall po tayo sa webinar natin noong Wednesday, just perform a t-test. So perform a t-test for one population mean, but please take note, you are not performing a t-test on your independent variables or your dependent variables. You are performing a t-test on your error terms. Okay? So since mean yung pinag-uusapan, so for this one, formulate natin yung HO natin as yung mean ng mga error terms, or sometimes it's also denoted as the expected value of the error terms equal to 0. Tapos yung HA natin, that is the expected value of the error terms, this is not equal to 0. So for you to satisfy this assumption, dapat tayo ay mag-fail to reject ng null hypothesis sa ating test. Alright? Next assumption, the error terms have a common variance. One approach is to still construct a plot of the residuals versus the predicted values. Okay? The error terms exhibit a constant variance if the plot shows that the points are on a horizontal band. Okay? So random pa din dapat. Okay? For example, this one. In this example, or in the plot on the right, the points are randomly scattered and it is on a horizontal band. So we say that the errors have a constant variance. while the plot on the right shows that somehow there is a funnel shape. Nakikita po natin yan. Tama? So there is a funnel shape, meaning the variability of the residuals increases dramatically as your X values increases. Kaya nga po nag-increase din yung predicted values natin for Y. So in this case, this is a clear violation of the assumption of homogeneity or constant variance. But by using a test of hypothesis, pwede natin ma-check din yung assumption ng constant variance. You can perform any of these tests. Okay? There are a lot more actually. Pero ito po yung usually ginagamit natin for checking this assumption. Assumption number 6, the error terms are uncorrelated with the independent variable. Oops, nakita natin yung term na uncorrelated. Correlation ulit. So more or less, may idea na tayo kung paano siya i-check. And we check it using a scatter plot. Or perform a test of hypothesis on the Pearson's correlation coefficient. All right, so going back to our example, success in college, the director of the Office of Admissions at a local college, again, would like to predict the GWA based on CAT score. Now, in our problem, we consider our dependent variable Y as the general weighted average, while we consider our independent variable X as the college admission test score. Based on this information and based on the collected data, let's check on the assumptions. First, the linear model is reasonable. Here's the residual versus the fitted values plot. And we see that the points are randomly scattered all throughout the scatter plot. So, the linear model is appropriate. Second, the error terms are independent. Going back to our problem, we do not have a data that is collected over time. Tama? Or yung data naman po natin, hindi rin siya collected in a certain order. In this case, we don't need to perform tests of hypothesis o kaya po i-check yung scatter plot because yung data collection natin already guaranteed that our observations and error terms are independent. Kasi randomly selected po yung mga students natin from which our observations in the study were collected. Okay? 3. The error terms are approximately normally distributed. So here's the QQ plot. So in the QQ plot, somehow the points lie close to that straight line. Pero pag empirical yung gusto nyong conclusion, let's use the Shapiro-Wilk test. And based on the Shapiro-Wilk test, we have p-value of 0.5527. And this indicates that we will fail to reject HO. And if we fail to reject HO, this means that the error terms are normally distributed. Fourth assumption, the error terms have a zero mean. And again, we'll use the t-test, and the p-value on our test is equal to 1. So this is, again, relatively large, so we fail to reject HO. So our conclusion would be the error terms have a zero mean. So check tayo dito na satisfy yung assumption. Fifth one, the error terms have a common variance. Here's the residual versus fitted plot. Okay? Di naman po natin nakita kanina yung common violation na may funnel shape tayo nakikita doon sa residuals versus fitted plot. But if you want to come up with an empirical conclusion based on this, we use a certain test procedure. And for this example, I use the non-constant variance score test. Kasi ito po yung readily available or yung sanay akong gamitin sa statistical software na ginagamit ko. P-value is 0.25916. Again, this is relatively large, so we fail to reject HO and conclude that the error terms have a common variance. And the last assumption, the error terms are uncorrelated with the independent variable. We use the t-test on the correlation coefficient And let's check on this p-value. It's equal to 1. So what do we say? We fail to reject HO and say that the error terms are uncorrelated with the independent variable. So lahat na assumptions, na-satisfy natin. So let's now proceed with the actual formulation of the linear regression model. Now, sa our commander output po, you will usually be provided with the estimate. Ito po yung B0 at B1 natin sa simple linear regression. Yung standard error, yung test statistic value, and yung p-value. Ito pong dalawa, iwan na natin ito mamaya. Okay? I-discuss din po natin yan later. Pero focus po tayo dito sa estimate saka sa standard error. Para po saan tong standard error? Remember, goal natin sa regression analysis is to make all the residuals as small as possible. So yung mga deviations na yon, magre-reflect po yun dito sa standard errors. Okay? And of course, yung estimate, ito yung gagamitin natin to formulate our equation, which is y hat I equal to 4.69967 minus 0.038962 exabyte. Now, if you will notice, yung B1 natin, or yung slope, negative yung value niya. And recall that in our preliminary analysis, R is also negative. And that is not surprising because the sign of your correlation coefficient and your slope or your regression coefficient should be the same. Okay? Now, I'd like to emphasize that in writing your regression equation, always specify the possible values of x because this equation was derived based on these values of x. In other words, ito pong line na to, totoo yan para dito sa values ng x. But we do not know yet if this line will also be true for values outside of the values of x that you used for your study. Okay. Now, practice po tayo ng interpretation. For example, B0 is 4.699677. Hey, now, important remark here is that it is not appropriate to interpret the regression constant since yung x values po natin did not include a value of x equal to 0. So here's a very important reminder. Be careful in making predictions or in interpreting the values found in your regression model. So I mentioned a while ago, this line is true for the values of x. But we don't know if it will also be true if we will predict y based on values outside of what you use in your analysis. Okay? So there is this danger of extrapolation. Yung po yung tawag sa mga statistics textbooks kung nare-recall po natin. Okay? Actually, yung danger na extrapolation, magsasend sa inyo ng signals. Paano po? Dito yon sa intercept usually. For example, your intercept suddenly became negative. Pero yung y mo, hindi siya pwedeng mag-negative. Ulitin natin yun ha. In your regression equation, you found that your intercept is negative. But your response variable by nature is not or should not be negative. So, ibig sabihin lang po nun, clear indication yon na yung line na nabuo natin based on our regression equation will not be true for values outside of what you use in your analysis. Okay? While going back to B1, which is negative 0.04, how do we interpret this value? This only means that the GWA of a student at the local university or local college is expected to decrease by 0.04 for every point increase in his or her CAT score. Now, we would also want to test hypothesis about our regression coefficient. And to perform this, we formulate the following HO. Beta 1 equal to 0 tells us that the slope of the regression line using all the values in the population is 0. Ano pong ibig sabihin nun? Simple lang po. Let's go back to the equation of the regression. Yung least squares regression line, y equals beta 0 plus beta 1 x plus your error or your residual. If beta 1 is equal to 0, what will happen to this part? Hindi po ba ito ay magiging equal lang din sa 0? So ano pong natira? It's only the regression constant. So ano pong ibig sabihin nun? Whatever the value of x, the expected response of y will always be equal to beta 0. So in other words, knowing the value of x would not help to predict the value of y. Yun po yung tinetest natin dito sa test of hypothesis for the regression coefficient. And similarly, your HA would tell us that your independent variable is linearly related to your dependent variable. Now, going back to our commander output, this time, balikan na po natin itong 2 columns na iniwan natin kanina. So, para po ito yun sa diniscuss natin kanina na pag-test ng regression coefficient. So, focus lang po tayo dito sa row for the college admission test. This is the test statistic value and this is the p-value. Notice that the p-value is very small, so we reject HO. So what can we say? We have sufficient evidence to say that the college admission test score is a useful linear predictor of the general weighted average of a student. Now, another approach to test the hypothesis of the significance of your regression coefficient is to use the F-test for regression. If you only have one independent variable, okay, the conclusions that would be generated from the t-test a while ago and the f-test should just be the same. In fact, same nga po. We will still reject our null hypothesis, so we will still say that the CAT score is a useful linear predictor of GW. Okay, now, again, ano po yung nakita nating steps sa simple linear regression? 1, is there a line that can summarize the relationship between the two variables? 2, if there is indeed a line, are there suspects that can contribute to the violation of certain assumptions in the regression analysis? If so, let's handle them. Let's perform data transformations as what you have realized during the webinars last Monday and Wednesday. And if you are now set to perform a regression analysis, the third step or the third question that needs to be answered is if there's indeed a line, how accurate can our predictions turn out based on this regression line? Okay? And we will do this by assessing our model. And there are several approaches or tools for assessing our model. The most common is the coefficient of determination that is usually denoted as R-squared. The coefficient of determination simply tells us the proportion of the total variation in the y values that can be explained by the linear relationship between x and y. Okay? Now for this one, okay, remember that we simply interpret the R-squared as part of the reason why the dependent variable varies is because of its linear relationship with your independent variable. And by theory po, or by computations, yung R-squared natin, based pa din po ito dun sa mga explanatory dun sa mga residuals na pinag-uusapan natin kanina. Okay? Bakit po? Notice or recall that the sum of the squared residuals is a natural measure of the variation in y. Yung nakita natin kanina. Okay? Aside from that, there's another variation that is present in your data. And that is the actual variation of y. Tama? Yung square deviation ng y natin doon sa mean ng mga y's. So we'll take the ratio of these two and come up with a measure that will tell us the percent or proportion of the total variation in the y values that can be explained by the relationship between x and y. So yun po yung basic idea ng R-squared. Now, going back to our R commander output, let's focus on this portion which says that R squared is equal to 0.7978. What does this tell us? Simply, 80% of the amount of the variation in the GWA can be explained by its linear relationship with CAP score. Now, in practice, and in some disciplines, we usually set a threshold for the R squared. Okay? Pero wala po tayong single value that will tell us if the R square is good, the R square is bad. Okay? Again, you just need to go back to what is practiced in your disciplines. Now, moving forward, this time, let us now go to the case wherein there are now more than one predictors or explanatory variables. So this is the case of the multiple linear regression. Again, the basic idea is that we will just extend the simple linear regression analysis by accommodating more than one explanatory variables. And the good thing is, hindi po tayo mag-reset ng discussion about regression analysis. Because the descriptive and inferential tools that we use in simple regression analysis would still be useful in multiple regression analysis with only little to no modification. So that means we still have the same set of assumptions. We'll still use the t-test for testing the significance of the coefficients. We'll still have the R squared. We'll still talk about residuals. And for this one, we consider this estimated regression line for the multiple linear regression. We have the y-intercept, or your estimated regression constant, which still has the same interpretation, the value of y when x is equal to 0. But this time, we have plenty of regression coefficients depending on the number of your independent variables. And same pa din po na interpretation, this is still the estimated effect of x on y, but since we are now considering more than one explanatory variables, this effect is true while holding the effect of other factors or other independent variables constant. Now, checking the assumptions, aside from the 6 assumptions that we discussed a while ago, an additional assumption is that there should be no multicollinearity. Ano pong ibig sabihin nito? The independent variables shouldn't be too correlated with one another. Or in other terms, no independent variable is a perfect linear function of the other explanatory variables. For this case, we check it using the variance inflation factor. A VIF equal to 1 indicates no multicollinearity. A VIF greater than 4 warrants further investigation, but a VIF greater than 10 is a clear violation of the assumption of no multicollinearity. And once again, there are a lot of other tools that you can use to check the assumption of no multicollinearity. The commonly used approach is the computation of the variance inflation factor. Another way to check it is the inconsistencies or changes of the signs of the coefficients with theory or practice. So for example, by theory, you know that if x increases, y should also increase. So meaning, yung coefficient between x and y should be positive. Kung sa multiple linear regression bigla siyang naging negative, then that is an indication of the presence of multicollinearity. Okay, so let's have this example. Can the eye pull the stomach? A study by Raghubir and Krishna examined the biases of consumers in the perception of volume due to container shape. The dimensions of 27 representative food products were collected. For this study, the dependent variable is the perceived volume, measured in milliliters, and we have the following independent variables. Height, measured in inches, maximum width of the product, measured in inches, minimum width of the packaging of the product, measured in inches, and the type of packaging material. That can be either glass, plastic, tin, or cardboard. Now notice, your Y is quantitative. Your X1, X2, and X3, yung height, maximum width, and minimum width of the packaging is also quantitative. But notice, the fourth variable, this is qualitative. And so far, what we have discussed is a regression analysis technique for Y that is quantitative and X that is also quantitative. Now, what would happen if one of your predictors is qualitative? How do we proceed with the regression analysis? The answer is by using dummy variables. So kung paano po yung layman's understanding natin ng term na dummy, ganun din po siya dito sa regression analysis. Dummy variables are artificial variables that would just take values 0 and 1. 0 would indicate the absence of the category of that certain independent variable, while 1 would indicate the presence of that certain category of your independent variable. For example, if your independent variable is qualitative with 2 categories, your regression equation would now look like this. So focus po tayo dun sa z sub I. Okay? Suppose itong z sub I or z, ito po yung qualitative variable natin with 2 categories. So since 2 categories lang siya, ang technique natin dito is somehow we are tricking the regression analysis. We would just assign values 0 and 1 to indicate presence or absence of that certain characteristic. Okay? But if you have 3 categories, ang nangyayari po dito is that we will have several dummy variables. So the number of dummy variables would be the number of categories minus 1. So sa case natin, since 3 categories po yung qualitative variable natin, meron tayong magiging 2 dummy variables. Okay? So yung Z1, again, 1 and 0 lang yung possible values niya, and we will use it to denote if an observation belongs to category 1. And yung second dummy variable, we'll use it to denote if the observation belongs to category 2. So basically, the coefficients that you will obtain from your dummy variables will simply reflect the change in the response as you move from one category to the other. And if you're using this under multiple linear regression analysis, hindi pa rin po nawawala na yung effects ng other predictors are held constant. Okay, going back to our example, okay, now this time, let us explore the no multicollinearity assumption. Now using the variance inflation factor, we have the following coefficients, and this clearly indicates that there is no indication of serious multicollinearity among the predictors. So it is still safe to proceed. Now, looking at our multiple regression equation, okay, still have the same format for your R commander output. You have your estimates and your standard errors. Formulating the equation, you have the following. Let's try. For example, how do you interpret a dummy variable with this coefficient? Focus po tayo dito. Yan. Nung ibig sabihin ng dummy variable na kinonstruct natin. If the product is packaged in glass, ang i-assign kong value for this dummy variable is 1. Yung i-assign ko namang value dito, 0. Dito, 0. Pero dito sa glass, since ang packaging niya po ay glass, 1 ang magiging value. Another example, para makuha natin. If your product is packaged in plastic, this one would be 0, this one would be 1, since ito yung dummy variable para dun sa plastic packaging, and this would be equal to 0. Next, if your product is packaged in tin, ibig sabihin ito, yung dummy variable for material glass would have a value 0. Dummy variable for the plastic would be 0. And dummy variable for the tin packaging would be 1. And lastly, if your material is packaged in cardboard, okay, ito na ngayon yung naging reference category natin. This would take value 0, this would take the value 0, and this would take the value 0. Okay? Now, interpreting the other coefficients, for example, height, okay, the perceived volume of a product is expected to increase by 44.14 ml for every 1 inch increase in the height of its container. Very important tong qualifier na to since nasa multiple regression tayo, holding other variables constant. Another thing, let's interpret, say for example, yung coefficient natin for the dummy variable for the glass packaging, this one. This coefficient tells us that the perceived volume of a product is expected to increase by 285.2 ml if its container is made from glass. Again, reference category, relative to cardboard, holding other variables constant. All right, so again, same format with a simple linear regression analysis. Let's assess our model. And one way to do it is by computing for the coefficient of determination, or R squared. But the thing is, by property, R squared will never decrease when another variable is added to a regression equation. Ito yung drawback niya. Tama? So, instead of using that simple R squared, we'll consider an improvement of this measure, the adjusted R squared. So, for pag multiple linear regression, I recommend to use the adjusted R squared since it takes into account both the sample size and the number of independent variables that was added in the model. And don't worry, the adjusted R squared has the same basic interpretation as that of R squared. For example, in our can the eye fool the stomach example, the adjusted R squared is equal to 0.8258. So what does this tell us? About 83% of the variation in the perceived volume of a product can be explained by its relationship with the dimensions of its container. Lastly, for the multiple linear regression, how do we test the hypothesis about your beta sub i's? Again, sa simple linear regression, we use the t-test. But since we have plenty of independent variables, the first thing you need to do is to test for the overall significance of the model. So to do it, you perform the f-test. And the f-test simply tells you if at least one of the population regression coefficients is different from 0. Review lang po natin, ulitin lang natin, pag sinabi mong different from 0, ibig sabihin po at least one of the variables, of the independent variables, has an effect on y. So, let's check first the overall significance of the model. And we'll use it or we'll check it using this p-value. Okay? So ito po yung nasa row for the f-test. Yan. And very obvious, it's very small, so we reject HO. Okay? So we can proceed with the t-tests for the individual coefficients. Why? Because again, f-test told us that at least one coefficient is significantly different from 0. So, going back to this output, you have the following p-values for your coefficients. And based on this, ang magre-reject lang ng HO na independent variable or coefficient, yung para sa height, at yung para sa packaging ng material using tin. So that means the height of a product and whether it is packaged in tin are useful linear predictors of its perceived volume. Okay? Now, final remark on model assessment. Sabi ko nga po kanina, there are a lot of other tools. Okay? Isang approach lang po yung R-squared. Isa pang approach, cross-validation. Pero ito, medyo computationally difficult na to. Because you will divide your original data into two segments. We call that the training data and the test data. So basically, ang nangyayari, kaya nga po siya tinawag na training and test data. So yung training, pwede natin gamitin siya, or yung isang part, or yung isang segment, doon sa data natin, pwede natin siyang gamitin to form the model. And sa pagpe-predict ng values, pwede natin i-check kung consistent siya doon sa isa pang segment na hinati natin based on our original data. So we will assess our model based on measures such as R-squared, root mean square error, or RMSE, and others. So some approaches, kung familiar po kayo, may tinatawag na hold-out validation, K-fold cross-validation, or leave one out cross-validation. Bitin lang po natin ha, yung idea ng cross-validation, you have this original data set, split mo siya into several segments. May segments doon na gagamitin mo to form a model, so makakapag-predict ka doon ng value for Y, and i-check mo ngayon yung difference ng predicted value na yon doon sa isa pang segment na nahati mo based on your original data. And the last part is on the logistic regression. So logistic regression is very broad. That's why I will only give a brief introduction of this technique. Okay? Now, the logistic regression analysis is used when your Y is categorical. So, the basic idea of the logistic regression analysis is that you are studying the relationship between a categorical response variable and explanatory variables which may be either qualitative or quantitative. Several forms. You have the binary logistic if your Y is dichotomous, meaning possible values na lang po ay 0 and 1. We have the multinomial logistic if your response variable has several nominal categories. And you have your ordinal logistic if your Y is ordinal. For this webinar, I'll present an introduction to the binary logistic regression model. And the binary logistic regression model simply tells us the probability that the event of interest will occur as a linear prediction of one or more predictors. If you will see, hindi po linear yung pattern na nakikita natin from the equation of a binary logistic regression model. But here are some properties. Since probability yung pinag-uusapan, it's still between 0 and 1. Second, based on this equation, as the x changes, the model shows an S-shaped distribution, which you will be seeing later. But if totally Y does not depend on X, the model will just exhibit a horizontal line. For example, this is an example of a distribution that will be reflected from a binary logistic regression model. So, what do we see here? First case, ito pong data greater than 0. Kita natin, S-shaped curve that slope upwards. So meaning, X has positive effect on the probability that the response will occur. On the other side, if your beta is less than 0, this portion, okay, x has a negative effect on the probability that the response will occur. So the steepness of the curve will actually tell us how quickly the probability that the response occur will rise or fall depending on the value of your predictor. Okay? Now, based on the equation that was shown earlier, it's clearly not linear. So in order to make statements about this, we first need to transform it into a linear form. And how do we do it? We make use of the concept of the odds. Okay? Odds, hindi po ito bagong concept sa atin. We often hear it as one that is related to probability or chance. So yung odds, it's a measure of the probability that the outcome of interest will occur over the probability that it will not occur for a particular group. For example, there is a 60% chance that it will rain tomorrow. So there is a 40% chance that it will not rain tomorrow. So the odds is 60 to 40, or 3:2. Now, we'll use this concept in our logistic regression equation. How? The odds that your response variable will occur is basically the numerator in your logistic regression equation. Okay? So that means beta greater than 0 indicates that for every unit increase in x, okay, or every unit increase in x increases the odds of y equal to 1 multiplicatively by t raised to beta. On the other hand, beta less than 0 tells us that every unit increase in x decreases the odds of y equal to 1 multiplicatively by t raised to beta. Okay? Now, baka may difficulty tayo sa pag-interpret nito. Kasi, paano natin i-imagine yung term na multiplicatively? So, transforming the odds, let's get the logic transformation of this. So we take the log odds, and now we are left with a linear transformation of your logistic regression equation. So ito na po yung nakikita natin kanina. Alpha plus beta. So beta greater than 0 means that every unit increase in x increases the log odds of y equal to 1 by beta. While beta less than 0 indicates that every unit increase in x decreases the log odds of y equal to 1 by beta. Now, last example, effective dose. A toxicity experiment was conducted to formulate a model relating the probability of fruit fly kill and nicotine concentration in grams per 100 cc. For this study, we were able to generate the following output, and clearly, same format pa din po ito, meron pa rin tayong estimates, standard errors, and tests for the significance of the coefficients. Okay? Now notice that for our example, we go back to the previous slide, okay? Ang response variable natin is fruit fly kill. So two possible values lang yan, kill or not kill. But our independent variable, nicotine concentration, is quantitative. So, applying the logistic regression analysis idea, we have the following equation. Again, we just derive these values based on what the output displayed. And now, how do we interpret these values? So, yung 0.2954, since ito na yung nagpapakita sa atin ng linear form, we use the interpretation of the log odds. So a 1 gram per 100 cc increase in nicotine concentration increases the log odds of killing the fruit fly by 0.2954. Okay? Now, another thing, pwede rin natin gamitin yung isang interpretation kanina using the odds. Okay? Pero kung mapapansin po natin, saan po nanggaling ito? This is just basically E raise your beta. Okay? Now, another example, Consider fitting a binary logistic regression model for energy requirement, meeting or not meeting, with the following as predictors: total energy intake, total iron intake, and sex. So obviously, yung response variable po natin is dichotomous. So, pwede natin gamitin yung binary logistic regression. For this case, we generated the following model based on the R output, and how do we interpret the coefficients? For example, let's concentrate on the coefficient for energy. So this value tells us that a 1 kcal increase in total energy intake increases the odds of meeting the energy requirement multiplicatively by 0.008, holding other factors constant. Okay? And the other one, yung 0.0077 would still follow the same interpretation, pero gusto ko pong mag-emphasize tayo na interpretation yung para doon sa female. Okay? This means that the odds of meeting the energy requirement decreases multiplicatively by 0.4858 if the individual is a female, holding other factors constant. Alright, so final thoughts on the regression analysis. First is communicate the results properly. As we have emphasized in our discussions, it is always important to include graphical displays of the relationship between two variables, because we will use this as our motivation for justifying if there is a linear relationship, if a linear regression analysis can be used to analyze the relationship between the two variables. Okay? Second, please take note that a model is a deliberate simplification of the reality. Anong message po natin dito? In choosing your predictors, make sure that your model retains the most important features of the reality and ignores the less important ones. In other words, a model that has many independent variables is not necessarily the best model. There are several approaches in statistics that we can use to select the best model. And take note, when choosing the best model, you do not blame your data. Baka kasi sabihin natin, pangit yung model kasi po pangit yung data. Okay? It is not the data that you should change. It is the model that you should change. So, complex process po ang modeling. Okay? It is an iterative process. Kung yung model mo hindi nag-significant, balik ulit doon sa pag-process or pag-investigate ng independent variables mo. Okay? So at the end of the day, it is you as the data analyst or as the modeler who gets to decide if your model is good or not. It's up to you to decide if you will use this independent variable or not. Always balance the trade-offs. And lastly, statistics is a toolbox. Ito po yung paulit-ulit kong sinasabi noong data visualization webinar series natin. Okay? It's not enough that you know the tool. You should know when and how to use a certain tool before actually applying it. Di ba po, parang sa toolbox lang. Alam mo na may martilyo, pero hindi mo gagamitin yung martilyo para mabaon yung screw. Alam mong may screwdriver, tama? Pero hindi mo gagamitin yung screwdriver para pampukpok sa pako para bumaon siya sa kahoy. Tama po? So, ganun din po sa statistical methods. Okay? In this 3-day webinar series, hindi naman po ito biglang naging crash course sa statistics. Okay? Ang intention po ng webinar series na to is to teach you on how to identify the most appropriate tool to use given the objective, given the nature of your data, and given the assumptions of the test that you intend to use. And at the same time, pinaka-importante doon is the interpretation of the results. More often than not, si statistician, bibigay sa'yo yung output. Okay? Si statistician, pwede niyang i-discuss kung anong ibig sabihin ng mga measures doon sa output, ng mga p-values, Pero paano pag nalimutan mo? Diba? So at least, by attending this webinar series, by this 3-part webinar series, you already know how to interpret this value. So always remember, statistics is a toolbox. You should know when and how to use a certain statistical tool before applying it. Okay? And that's all. Okay? It's a very productive 3-part webinar series, okay, delivered by LRC and the UPLB Institute of Statistics. So maraming salamat po sa pag-attend. And again, if you have further questions or if you need the help of a statistician, the Institute of Statistics has a statistical consulting group. Okay? You may check our website, instat.uplb.edu.ph. Meron na po kaming link doon sa homepage namin for our statistical consulting services. So thank you very much, and I will now turn over the Zoom space to Ma'am Sherry.
Thank you so much, Sir Enzo, for sharing with us your knowledge and expertise on statistics. So don't forget, guys, sabi ni Sir Enzo, statistics is a toolbox. You have to know when and how to use those statistical tests. Ano? Laging ibabalik sa iyo ni Sir. Naalala kita, Sir. Lagi mo sa akin nasabihin, anong objective mo, ma'am? Anong objective sa research? Kasi doon siya magbabase talaga. So, kailangan malinaw na agad kung ano yung mga objectives mo. Alright? Ang dami nating natutunan, guys, no? On how to determine the correct statistical tools dun sa ating mga variables para malaman yung correlations. What are your major takeaways? Sabihin niyo po yan sa ating comment section box. Also, pinost ko po yung page po ng Instat kung gusto po ninyong humingi ng tulong sa kanila. Kagaya ko po, humingi ako ng tulong sa Instat for my research. I-check nyo lamang po yung page nila for the Statistical Consulting Group. Okay? So we are seeing your comments po. Even our speaker, Sir Enzo, is also seeing your comments sa ating comment section box. Maraming salamat po na sinasabi niyo po na marami kayong natutunan from our sessions, lalong-lalo sa session ni Sir Enzo. No? It's 3 hours, grabe, 3 hours na talagang pinuno niya tayo ng learnings. All right, so the Zoom space is now open for your questions. Again, just please keep your comments helpful and considerate and ask relevant questions sa ating topic. Meron lang pong nag-comment kanina, sabi niya, grabe, napakagaling, I'm amazed. Iniisip pa lang daw po niya yung statistical tool na gagamitin niya for correlation. Ngayon, alam na daw po niya kung anong gagamitin. Okay. We have a question from Mario Somera. Sabi niya po ay, meron daw po ba tayong module on how to do stat in MS Excel? I guess yung sa webinar series natin, sir, ano po, yung sa making sense of data, yung first or yung second part, tama po ba? Doon natin sila binigyan ng idea on how to use Excel for data analysis.
Kami naman ng mga tools online, mga tutorials online, para matuto tayo kung paano mag-analyze ng data using MS Excel. Okay? So again, ang very important reminder ko lang po dito, since tools are already available online and offline, make sure to always check the assumptions. Okay? Kaya po yung style ng discussion natin was to always check the assumptions first before analyzing the data. Because there is a danger of coming up with erroneous conclusions if the assumptions of the test are violated.
I think, sir, may nakita po ako na isang question doon. Pero I guess na-answer na rin po yata yun dun sa session 2 natin. Baka hindi lang niya na napanood. What if daw may na-violate na isa, sir, na assumption? Ano daw po yung gagawin niya?
Okay po. Again, pag na-violate yung assumptions po natin, kung ma-recall po natin sa discussion ni Prof. Mananghaya, may parametric, may non-parametric test. So for example, sa discussion natin, yung parametric ng correlation analysis, yung Pearson's. Pag na-violate po yung assumptions ng Pearson's, you can proceed with the Spearman's correlation analysis. And another thing, halimbawa po sa chi-square test, kung na-violate yung assumptions ng chi-square test, pwede naman po yung Fisher's exact test. Okay. So there are always alternatives. So hindi naman po end of the road lagi kapag na-violate yung assumptions ng test natin.
All right. I hope that answers your question. Thank you, Sir Enzo. Another question po from Mark Kevin Samson. Sabi niya, sir, ito sa first part po ito na i-comment or na itanong, is count data the same as phi coefficient?
Kung naalala nyo po, yung phi coefficient po natin kanina, it's a measure of the strength of association. Okay? So yung phi coefficient na pinakita po natin kanina, gagamitin mo yun given na nakita mo that the two qualitative variables are associated. Kasi sa chi-square test, ang alam mo lang, associated sila or hindi. But how strong is the association, dun mo na po kailangan ngayon ng mga chi-square based measures of association such as the phi coefficient.
Okay. Ito sir, may kay Bernadette Lim naman sir. I hope that answers your question, Mark, no? Now, another question from Bernadette Lim, sabi niya po ay, is the VIF check for variable multicollinearity also applicable to variables in categories used for logistical regression analysis? How will the form of codes be when entering it in the software?
Pag may dummy variables po tayo, hindi naman po ganun masyadong kalaki yung data preparation na kailangan natin. Because ang good news, yung mga statistical softwares natin, kaya niya na mag-handle. Siya na mismo mag-perform ng pagdami ng mga variables. So, kung paano mo siya in-enter, ganun pa rin naman po siya, i-analyze sa statistical software. Just make sure na pag in-specify mo na siya dun sa model, you will tell the statistical software that it is a qualitative variable.
Okay. Thank you, Sir Enzo. Bernadette, I hope that answers your question. I guess yun na po yung mga questions natin for this morning. If si Sir Enzo naman po masipag po yan mag-comment sa mga may questions sa FB Live. So if he has time, he will reply to you po. But at this point in time, sir, any parting words po sa ating mga viewers?
Alright. Okay, so correlation and regression analysis, or in general, modeling, is a very complex process. Yung pinakita po natin today is just a glimpse of what is there. So, basic tools lang yon, basic concepts lang yon sa modeling. Pag pinag-usapan natin yung modeling, meron pa po yan yung para sa time series data, meron pa po yan sa ibang mga nature or types ng data na pwede nating i-analyze. Okay? Just always remember, there are many possible ways on how you can analyze the data. At the end of the day, you should just check if that tool that you use answered your objective. Kasi yun naman po yung purpose natin kung bakit tayo nag-analyze ng data, kung bakit tayo gumagamit ng statistical tool. We want to answer a certain research question. So I hope you learned the basics of correlation and regression and never stop learning. Marami pa pong mga tools sa statistics na pwede kayong gamitin. Just always make sure to use it properly. Thank you po.
There you have it, guys. Professor John Lorenzo A. Yambot. Thank you so much, sir. Now, again, thank you for inspiring us to see the beauty of correlations, of statistics, by learning the relationships among variables. Now, hashtag Team LRC would like to take this opportunity to thank you, sir, for being our speaker and for your valuable time. So, to award the Certificate of Appreciation, may I kindly recognize our beloved director, Dr. Benjamina Paula G. Flor.
Thank you so much, Prof. Enzo. Once again, you made our day. So, doon sa mga listeners natin, sa mga viewers natin, I hope this is another milestone in your statistics journey. So, sa explanation ni Sir Enzo, parang ang dali lang pala ng statistics, pero ang sabi niya, it's complex. So parang ano pa lang yan, tip of the iceberg. So keep your lines open. So Sir Enzo is also open for consultation. Hindi ko lang alam kung libre, baka hindi. So bahala na lang kayo mag-usap ni Sir Enzo. But the point is, you're able to seek expert opinion on what kind of analysis would be most appropriate in analyzing your data. Nung panahon ko, nung ako'y nag-PhD, ay talagang we have to defend our statistical tool to be used to analyze our data sa Institute of Statistics. No? Dahil way back pa naman yon. So ngayon daw wala nang ganun. So swerte siguro nila. But at the same time, swerte din namin kasi we know what's behind the data. So yung interpretation, we don't just leave it to the statistician. Di ba? Usually ngayon sinasabi namin, consult a statistician kasi hindi naman ako a statistician. No? Pero it's good to know the kumbaga sa computer yung beta version, no? yung back end alam natin instead of just interpreting what the statistical software would give you. Sa dami-dami ng data ay talagang ma-overwhelm ka. Kaya nga with this webinar, we are so grateful for the participation, for the partnership of the Institute of Statistics of the University of the Philippines, Los Baños.
All right, thank you, Ma'am Benj. Allow us to present to you, sir, the Certificate of Appreciation. Allow me to read the citation. University of the Philippines, Los Baños Learning Resource Center present this Certificate of Appreciation to John Lorenzo A. Yambot for serving as resource speaker in the third session on Are We Correlated? Relationship among variables in the One Stat at a Time, a webinar series on basic statistical tools and techniques in research held today, November 27, 2020, given this 27th day of November 2020 at the Learning Resource Center, UPLB College, Laguna, signed by our director, Benjamina Paula G. Flor. And at this point in time, also, we would like to thank the equally beautiful director of Institute of Statistics for allowing us to partner with them for this webinar series, which is hashtag one stat at a time. Let me also read the citation. This Certificate of Appreciation, University of the Philippines, Los Baños, Office of the Vice Chancellor for Academic Affairs, Learning Resource Center, present this Certificate of Appreciation to UPLB Institute of Statistics for serving as our partner in the webinar series, One Stat at a Time, a webinar series on basic statistical tools and research given this 27th day of November 2020 at the Learning Resource Center, UPLB College, Laguna, signed again by our director, Ma'am Benji Flor. Ma'am Lisa, any message po to our participants?
Yes, sa mga participants, thank you for joining this webinar for the past 3 days. I hope na aside from the learnings na nakuha natin from Monday, Wednesday, and today, sana na-appreciate din natin yung statistics na sana na-dispel na rin yung mga fears sa mga researchers na gumagamit ng mga statistical tools kasi talaga naman very useful siya. Hindi ko sinasabi ito dahil stat kami pero talagang useful siya at makaka-help sa pag-decide sa mga researchers nyo. So thank you sa pag-join at congratulations sa LRC, Ma'am Benj, sa maraming yung mga supporters sa inyong mga webinar. I hope na hindi nga po ito ang ating unang pag-join. It is a pleasure. It was a pleasure working with you. Hindi siya mukhang work kasi napaka-pleasant po mula sa iyo, kay Cheryl, kay Joshua, kay Sir Mark Lester Chico, lahat yan. So nag-enjoy naman po kami. So thank you po ng marami.
6,000 plus tayo ngayon, ma'am. Registrants.
Yay, congratulations.
Thank you so much, Ma'am Lisa. Thank you, Sir Enzo. Thank you, Ma'am Bench. Sabi nga dun sa favorite quote ko po, individually, we are just one drop. Pero together, we are an ocean. So, maraming salamat po. Sana po ay marami pa tayong ganitong sessions. Okay, now for the evaluation of this session, guys, do not forget to answer the evaluation form after this webinar. It will be sent to your email at around 12:30 in the afternoon. Your comments and suggestions will be deeply appreciated by our team, hashtag Team LRC, and of course also the Insta team. The evaluation link will be sent only to those who successfully registered for the event. You have until 7 p.m. today to send in your responses and give us at least 48 hours to generate your certificates as well. But then again, guys, lagi namin sinasabi, apart from the certificates, more than the certificates, we hope you gain valuable insights from our session of the One Stat at a Time webinar series. At this point, we would like to recognize and thank our team, hashtag Team LRC and hashtag One Stat at a Time team, headed by our director, Ma'am Benji, with the support of our Vice Chancellor for Academic Affairs, Dr. Jane O. Loyola. On our technical side is our University Research Associate, Joshua Michael G. Jonas, and of course, our webinar production online director, Direct, Prof. Mark Lester and Chico. Muli nagpapasalamat po kami sa Instat team po kay Ma'am Lisa, kay Sir Mon, kay Ma'am Dale, kay Ma'am Ange, and of course, sa ating speaker for our last session, si Sir Enzo. And we would like to thank our two other members of Team LRC, which is birthday po today ng aming queen, si Tita Allen. Ayan, happy birthday, Tita Allen. Kay Kuya Iwok din po, hindi man po sila kita dito sa ating Zoom space, sa aming screen. Sama-sama po ang Team LRC palagi sa aming mga programs. All right, indeed, TGIF. Thank God it's Friday. This concludes our webinar series. This has been your moderator for today's session, Cheryl Hermosa Ebron. Ang ating mga research, guys, or thesis ay para ding pag-ibig. Kung mahal mo, huwag mong iwanan, huwag mong bitawan, kundi ipaglaban. Halimbawa mang madapa at masaktan, tayo lang ulit, laban ulit at mag-move on sa experiments. Darating din ang tamang panahon, marirealize mo, hindi naman pala dapat maging komplikado. Sa dulo, positively correlated din pala kayo. Sa bawat hamon ng buhay, keep choosing to move on and move forward. Yes, everything is interconnected and related, but it's not really complicated at all. Everything can be done one step at a time or one step at a time. One step at a time, matatapos din ang thesis mo, thesis natin at research natin. Muli, maraming salamat sa pagtutok. Stay happy, stay positive everyone. Keep safe and God bless. Bye!